What if the key to unlocking the stars isn't found in the blazing light of distant suns, but in the shadowy, unseen threads woven throughout the cosmos? Imagine a force so vast, so mysterious, that it makes up more than 85% of the universe's mass, yet remains invisible to our eyes and undetectable by conventional means. This is dark matter, a cosmic enigma that has puzzled scientists for decades. But what if this invisible fabric of the universe holds the secret to interstellar travel? What if the very thing we can't see could propel us to the farthest reaches of space? In this video, we're diving into 50 groundbreaking theories on how dark matter could revolutionize space travel. From propulsion systems that defy our current understanding of physics to energy sources that could power spacecraft for millennia, these ideas aren't just science fiction, they're the cutting edge of futuristic technology. So, buckle up and prepare to explore the invisible frontier. By the end of this journey, you'll see the universe in a whole new light, one where the unseen becomes the key to the unimaginable. Let's begin. Now, let's dive into the first theory, dark matter propulsion. Picture this: what if the very substance that makes up most of the universe's mass could also power our journey to the stars? Dark matter, with its mysterious and invisible nature, might hold the key to a propulsion system unlike anything we've ever imagined. Unlike traditional rocket fuel, which burns out quickly and limits our reach, dark matter could provide a continuous source of thrust, potentially allowing spacecraft to travel farther and faster than ever before. The idea revolves around harnessing dark matter's unique properties. Since it doesn't interact with light or ordinary matter in the way we're used to, it could theoretically be used to generate propulsion without the need for bulky fuel tanks. Imagine a spacecraft that doesn't need to carry tons of fuel but instead taps into the invisible energy surrounding it. This could revolutionize space travel, making long-distance missions more efficient and sustainable. But here's the catch: detecting and manipulating dark matter is no easy task. Scientists are still working to understand its exact nature and how it behaves. Current experiments, like those using particle detectors deep underground, aim to catch even the faintest traces of dark matter interactions. If we can figure out how to capture and control it, the possibilities are staggering. Ongoing research is already exploring how dark matter could be used in propulsion systems. Some theories suggest that dark matter particles could be directed or accelerated to create thrust, while others propose using its gravitational effects to propel spacecraft. While these ideas are still in their early stages, they represent a bold step toward a future where dark matter isn't just a cosmic mystery, it's the engine that drives us to the stars. As we continue to unravel the secrets of dark matter, one thing is clear: the potential for propulsion is just the beginning. Next, we'll explore how dark matter could be harvested for energy, opening up even more possibilities for the future of space travel. Now, let's shift our focus to another groundbreaking idea: harvesting energy from dark matter. Imagine if we could tap into the invisible particles that fill the cosmos, not just for propulsion, but as a limitless energy source. This theory suggests that dark matter interactions could be converted into usable energy, offering a revolutionary way to power spacecraft on missions that span years or even decades. Dark matter, as we know, doesn't interact with light or ordinary matter in the way we're familiar with. But what if its unique properties could be harnessed to generate energy? Some scientists propose that dark matter particles, when they collide or interact, release energy that could be captured and converted. This energy could then be used to power everything from life support systems to advanced propulsion technologies, making long-duration space travel not just possible but sustainable. Think about it: traditional energy sources like solar panels or nuclear reactors have their limits. Solar panels lose efficiency the farther we travel from the sun, and nuclear reactors come with their own set of challenges, including safety and resource limitations. Dark matter, on the other hand, is everywhere. if we could find a way to harvest its energy, spacecraft could essentially refuel as they travel, drawing power from the very fabric of the universe. Of course, this idea is still in its infancy. One of the biggest hurdles is detecting dark matter particles in the first place, let alone figuring out how to extract energy from them. Current experiments, like those using highly sensitive detectors in deep underground labs, are working to identify even the faintest traces of dark matter. If we can crack the code of how these particles behave, the next step would be developing the technology to capture and convert their energy. Some theories suggest that dark matter particles could be directed into specialized reactors, where their interactions would release energy in a controlled manner. Others propose using dark matter's gravitational effects to generate power indirectly. While these concepts are still speculative, they represent a bold vision for the future, a future where dark matter isn't just a cosmic mystery, but a cornerstone of interstellar exploration. As we continue to explore the possibilities, one thing is certain: the potential for dark matter energy harvesting could redefine how we think about powering our journey through the stars. Next, we'll delve into how dark matter's gravitational effects could be used as a tool for space travel, opening up even more exciting possibilities. Now, let's turn our attention to an idea that sounds like it's straight out of science fiction but could one day become a reality, using dark matter as a gravitational lens. Picture this: what if we could harness the immense gravitational pull of dark matter to bend light itself, creating a kind of cosmic magnifying glass that could propel spacecraft at speeds we've only dreamed of? This theory takes the concept of gravitational lensing, a phenomenon predicted by Einstein's theory of relativity, and applies it to the invisible web of dark matter that permeates the universe. Gravitational lensing occurs when massive objects, like galaxies or black holes, warp the fabric of space-time so much that they bend the path of light passing near them. Dark matter, with its enormous gravitational influence, could theoretically do the same. By positioning a spacecraft in just the right spot, we might be able to use dark matter's gravitational field to focus and amplify light or other energy sources, effectively creating a slingshot effect that accelerates the craft to incredible speeds. Think of it as using the universe's own infrastructure to give us a boost. But how feasible is this idea right now? It's still in the realm of theoretical physics. One of the biggest challenges is mapping the distribution of dark matter with enough precision to identify where these gravitational lenses might form. We'd also need to develop technology capable of navigating and positioning spacecraft within these complex gravitational fields. And let's not forget the energy requirements. While dark matter's gravity could help us accelerate, we'd still need a way to control and sustain that acceleration over vast distances. Despite these hurdles, the potential is staggering. If we could master this technique, it could drastically reduce travel times between star systems, making interstellar exploration far more practical. Imagine a future where spacecraft ride the gravitational waves created by dark matter, zipping across the galaxy at speeds that would make today's propulsion systems seem like horse-drawn carriages. Of course, this vision will require breakthroughs in both our understanding of dark matter and our technological capabilities. We'd need advanced sensors to detect and map dark matter's gravitational effects, as well as propulsion systems that can take full advantage of these cosmic shortcuts. But if we can overcome these challenges, dark matter gravitational lensing could revolutionize space travel, turning the invisible into the indispensable. Next, we'll explore another fascinating possibility: using dark matter to create protective shields around spacecraft, shielding them from the dangers of deep space. Stay tuned as we dive into how this mysterious substance could become our ultimate cosmic armor. Now, let's shift our focus to a theory that could transform the safety of space travel, using dark matter to create protective shields for spacecraft. Imagine a shield so advanced that it could protect astronauts and their vessels from the harsh realities of deep space cosmic radiation, micrometeoroids, and other hazards that make interstellar journeys perilous. This idea hinges on the unique properties of dark matter, which could potentially be harnessed to form an invisible barrier around spacecraft, offering unprecedented levels of protection. The concept revolves around dark matter's gravitational influence and its ability to interact weakly with ordinary matter. Cosmic radiation, which consists of high-energy particles, poses a significant threat to both spacecraft and human health during long missions. Similarly, micrometeoroids, tiny particles traveling at incredible speeds, can cause catastrophic damage to spacecraft. A dark matter shield could theoretically deflect or absorb these threats, acting as a cosmic force field. The idea is to use dark matter's gravitational pull to create a dense, protective layer around the spacecraft, effectively bending the paths of harmful particles away from the vessel. But how would this work in practice? One possibility is to use dark matter's gravitational field to create a kind of gravitational lens around the spacecraft, similar to how it bends light. This lens could redirect incoming radiation and micrometeoroids, preventing them from reaching the ship. Another approach involves using dark matter particles themselves to absorb or scatter harmful particles, much like how Earth's atmosphere protects us from solar radiation. The challenge lies in figuring out how to manipulate dark matter in such a precise way, as it doesn't interact with light or electromagnetic forces in the same way ordinary matter does. The potential applications of this technology are immense. A dark matter shield could make long-duration space missions far safer, reducing the risks of radiation exposure and spacecraft damage. It could also enable missions to regions of space that are currently too hazardous to explore, such as the intense radiation belts around Jupiter or the debris-filled regions of asteroid belts. Moreover, this technology could extend the lifespan of spacecraft, allowing them to operate for decades without succumbing to the wear and tear of cosmic hazards. Of course, there are significant hurdles to overcome. We still don't fully understand how to detect or manipulate dark matter, let alone shape it into a functional shield. Advanced sensors and new technologies will be required to map and control dark matter's gravitational effects with precision. Additionally, we'd need to develop materials and systems capable of integrating dark matter into spacecraft design without disrupting their functionality. Despite these challenges, the idea of dark matter shields opens up exciting possibilities for the future of space exploration. If we can unlock the secrets of this mysterious substance, we might one day equip our spacecraft with the ultimate cosmic armor, making the stars a little safer to reach. Next, we'll dive into an even more mind-bending concept, using dark matter to create warp bubbles, potentially enabling faster than light travel. Stay with us as we explore how this elusive substance could rewrite the rules of space-time itself. Now, let's venture into a concept that sounds like it's straight out of science fiction but could one day become science fact, using dark matter to create warp drives. Imagine a spacecraft that doesn't just travel through space but bends the fabric of space-time itself, allowing it to move faster than the speed of light. This idea, often associated with the famous warp drive concept, could revolutionize interstellar travel, and dark matter might just be the key to making it possible. At the heart of this theory lies the idea of a warp bubble. In simple terms, a warp bubble would compress space-time in front of a spacecraft while expanding it behind, effectively creating a shortcut through the cosmos. Instead of moving through space, the spacecraft would ride this bubble, bypassing the limitations imposed by the speed of light. But how does dark matter fit into this? Dark matter's unique gravitational properties could be harnessed to manipulate space-time in this way, creating the conditions necessary for a warp bubble to form. The theoretical physics behind this concept is rooted in Einstein's theory of general relativity, which describes how massive objects can warp space-time. Dark matter, with its immense gravitational influence, could act as the engine for a warp drive, bending space-time in a controlled manner. One proposed method involves using dark matter to generate negative energy, a hypothetical form of energy that could counteract the positive energy of ordinary matter. This negative energy would be essential for creating the warp bubble, as it would allow space-time to contract and expand in the necessary way. But why dark matter? Unlike ordinary matter, dark matter doesn't interact with light or electromagnetic forces, making it an ideal candidate for manipulating space-time without the interference of other particles. Its gravitational effects could be fine-tuned to create the precise distortions needed for a warp bubble, potentially enabling faster than light travel without violating the laws of physics as we understand them. The challenges, however, are immense. For one, we still don't fully understand how to detect or manipulate dark matter, let alone harness it for such an advanced application. Creating a warp bubble would require an enormous amount of energy, and we'd need to develop technologies capable of generating and controlling that energy with extreme precision. Additionally, the effects of such a warp bubble on the spacecraft and its occupants would need to be carefully studied to ensure safety and feasibility. Despite these hurdles, the potential rewards are staggering. A functional warp drive could reduce travel times between star systems from thousands of years to mere months or even weeks, opening up the galaxy to exploration and colonization. It could also provide a way to study distant regions of the universe that are currently beyond our reach, offering new insights into the nature of space, time, and dark matter itself. As we continue to explore the mysteries of dark matter, the dream of faster-than-light travel may one day move from the realm of science fiction into reality. The possibilities are as vast as the universe itself, and the journey to unlock them is just beginning. Next, we'll explore how dark matter could be used to manipulate space-time in an even more profound way, by creating shortcuts or wormholes for interstellar travel. Stay tuned as we delve into this groundbreaking idea. Now, let's take a step further into the realm of the extraordinary and explore how dark matter could serve as a space-time manipulator, potentially creating shortcuts or wormholes for interstellar travel. This concept, while deeply rooted in theoretical physics, offers a tantalizing glimpse into how we might one day traverse the vast distances of the cosmos with ease. At its core, the idea revolves around the manipulation of space-time itself. Imagine a tunnel-like structure connecting two distant points in the universe, allowing a spacecraft to travel from one end to the other in a fraction of the time it would take using conventional methods. These hypothetical tunnels, known as wormholes, could be the ultimate shortcut for interstellar travel, and dark matter might hold the key to making them a reality. The role of dark matter in this scenario is tied to its gravitational properties. Dark matter's immense gravitational influence could be used to bend and shape space-time in such a way that a stable wormhole could form. Unlike ordinary matter, dark matter doesn't interact with light or electromagnetic forces, making it an ideal candidate for creating the precise distortions needed to sustain a wormhole. By concentrating dark matter in specific regions, we might be able to generate the necessary curvature in space-time to open and maintain these cosmic passageways. However, the challenges are as immense as the possibilities are exciting. For one, wormholes are inherently unstable. According to current theories, they would require an exotic form of matter or energy with negative mass to keep them open and prevent them from collapsing. Dark matter, with its unique properties, could potentially provide this stabilizing effect, but we're still far from understanding how to harness it in such a precise manner. Additionally, the energy requirements for creating and maintaining a wormhole would be astronomical, far beyond anything we can currently achieve. Another major hurdle is the potential impact on the spacecraft and its occupants. Traveling through a wormhole would expose them to extreme gravitational forces and space-time distortions, which could have unpredictable effects. Ensuring the safety and feasibility of such a journey would require groundbreaking advancements in both physics and engineering. Despite these challenges, the potential rewards are nothing short of revolutionary. A functional wormhole could allow us to travel to distant star systems in a matter of hours or days rather than centuries. It could also provide a way to study regions of the universe that are currently beyond our reach, offering new insights into the nature of space, time, and the cosmos itself. As we continue to unravel the mysteries of dark matter, the dream of creating wormholes for interstellar travel remains a bold and inspiring vision. The journey to unlock this potential is filled with challenges, but the possibilities it opens up are as vast as the universe itself. Next, we'll shift our focus to how dark matter could revolutionize navigation systems for spacecraft, enabling precise travel through the cosmos. Stay tuned as we explore this fascinating idea. Now, let's navigate into a fascinating new frontier: how dark matter could revolutionize the way we guide spacecraft through the cosmos. Imagine a future where the invisible gravitational web of dark matter becomes our cosmic GPS, enabling spacecraft to traverse the universe with pinpoint accuracy. This is the promise of dark matter-based navigation systems, a concept that could redefine interstellar travel as we know it. At the heart of this idea lies dark matter's gravitational influence. Unlike visible matter, dark matter doesn't emit light or interact with electromagnetic forces, but its gravitational pull is immense. This makes it a perfect candidate for creating a universal navigation framework. By mapping the distribution of dark matter across the universe, we could use its gravitational signatures as natural landmarks, guiding spacecraft through the vast emptiness of space with unprecedented precision. Here's how it could work. Dark matter forms a cosmic scaffold, shaping the large-scale structure of the universe. Galaxies, clusters, and even the voids between them are all influenced by dark matter's gravitational pull. By detecting and analyzing these gravitational patterns, spacecraft could determine their position relative to these invisible markers. Think of it as using the gravitational equivalent of stars or constellations, but on a much grander scale. This method would allow spacecraft to navigate through regions of space where traditional star-based navigation systems might fail, such as in the depths of intergalactic space or near black holes where light is distorted. One of the most exciting aspects of this theory is its potential for long-duration missions. Current navigation systems rely heavily on Earth-based signals, which become weaker and less reliable the farther a spacecraft travels. A dark matter-based system, however, would be self-sufficient, using the gravitational framework of the universe itself as a guide. This could be a game-changer for missions to distant star systems or even other galaxies, where real-time communication with Earth is impossible. Of course, there are significant challenges to overcome. Detecting and mapping dark matter's gravitational influence with the precision required for navigation is no small feat. Current technology is still in its infancy when it comes to directly observing dark matter, let alone using it as a navigational tool. Additionally, the algorithms and computational power needed to process this data in real time would be immense. But as our understanding of dark matter grows and our technological capabilities advance, these hurdles may become surmountable. The implications of this technology are profound. Not only would it enable more accurate and efficient space travel, but it could also open up new possibilities for exploration. Imagine spacecraft venturing into uncharted regions of the universe, guided by the invisible hand of dark matter. It's a vision that combines the cutting edge of physics with the timeless human desire to explore the unknown. As we continue to unlock the secrets of dark matter, the dream of using it as a cosmic navigation system moves closer to reality. The journey to harness this potential is filled with challenges, but the rewards could be nothing short of transformative. Next, we'll explore how dark matter might serve as a direct fuel source for spacecraft, offering a new way to power our voyages through the stars. Stay with us as we dive into this groundbreaking idea. Now, let's shift our focus to an idea that could redefine how we power our journeys through the cosmos: dark matter as a fuel source. Imagine a spacecraft that doesn't rely on conventional fuels like chemical propellants or even nuclear energy, but instead taps into the immense energy potential of dark matter. This concept could revolutionize space travel by offering a fuel source that is not only incredibly efficient but also abundant throughout the universe. At the core of this theory is the energy density of dark matter. While we still don't fully understand its properties, scientists believe that dark matter particles could contain vast amounts of energy. If harnessed, this energy could far surpass the capabilities of traditional fuels. For example, chemical rockets, which have powered space exploration for decades, are limited by the amount of fuel they can carry and the energy they can produce. Dark matter, on the other hand, could provide a much higher energy output with a significantly smaller amount of material, making it an ideal candidate for long-duration missions. One of the most compelling aspects of dark matter as a fuel source is its potential to eliminate the need for refueling. Traditional spacecraft must carry large quantities of fuel, which adds weight and limits their range. Dark matter, however, is thought to be distributed throughout the universe, meaning a spacecraft could theoretically harvest it as it travels. This would allow for missions of unprecedented duration and distance, opening up possibilities for exploring far-off star systems or even other galaxies. But how could we actually use dark matter as fuel? One possibility is through particle annihilation. If dark matter particles interact with their antimatter counterparts, they could release energy in a process similar to how matter and antimatter annihilate each other. This energy could then be converted into thrust, propelling the spacecraft forward. Another approach involves tapping into the gravitational energy of dark matter, using its immense pull to generate power for the spacecraft systems. While these ideas are still in the realm of theory, they highlight the incredible potential of dark matter as a fuel source. Of course, there are significant challenges to overcome. Detecting and capturing dark matter particles is no easy task given their elusive nature. We would also need to develop technologies to safely and efficiently convert dark matter's energy into usable power. Additionally, the physics behind these processes is still not fully understood, requiring breakthroughs in both theoretical and experimental science. However, as our understanding of dark matter grows, so too does the possibility of turning this mysterious substance into a practical fuel source. The implications of this technology are staggering. A spacecraft powered by dark matter could travel farther, faster, and more efficiently than anything we've built before. It could enable missions to distant star systems where traditional fuels would be impractical or impossible to use. And it could fundamentally change our approach to space exploration, making the cosmos more accessible than ever before. As we continue to explore the mysteries of dark matter, the idea of using it as a fuel source becomes increasingly tantalizing. While the challenges are immense, the potential rewards are equally extraordinary. Next, we'll delve into how dark matter could revolutionize interstellar communication, enabling real-time connections across the vast distances of space. Stay with us as we uncover this next groundbreaking possibility. Now, let's turn our attention to a concept that could transform how we stay connected across the cosmos: dark matter communication networks. Imagine a future where spacecraft, no matter how far apart, can communicate in real time, as if they were just a phone call away. This idea hinges on the unique properties of dark matter, which could serve as the backbone for an interstellar communication system unlike anything we've ever seen. At the heart of this theory is the idea that dark matter's gravitational influence could be harnessed to transmit information across vast distances. Unlike traditional communication methods, which rely on electromagnetic waves like radio signals, dark matter-based networks could bypass the limitations of light speed delays. This means that messages could travel faster and more efficiently, enabling real-time communication between Earth and distant spacecraft or even colonies on other planets. One potential approach involves using dark matter's gravitational waves as a medium for transmitting data. Just as ripples in a pond carry energy, gravitational waves generated by dark matter interactions could carry encoded information. By detecting and decoding these waves, we could create a network that spans the galaxy, allowing for instant communication across unimaginable distances. This would be a game-changer for interstellar missions, where delays in communication could mean the difference between success and failure. Another intriguing possibility is the use of dark matter particles themselves as carriers of information. If we could manipulate dark matter particles to encode data, we might be able to send messages through the fabric of the universe itself. This method would rely on advanced technologies to detect and interpret these particles, but the payoff would be a communication system that operates seamlessly across the cosmos. Of course, there are significant challenges to overcome. Detecting and manipulating dark matter particles remains one of the greatest scientific hurdles of our time. We would also need to develop entirely new technologies to encode, transmit, and decode information using dark matter. Additionally, the physics behind these processes is still largely theoretical, requiring breakthroughs in both our understanding of dark matter and our ability to engineer solutions around it. Despite these challenges, the potential benefits are immense. A dark matter communication network could enable real-time coordination between spacecraft, allowing for more efficient exploration and resource management. It could also facilitate communication with distant colonies, fostering a sense of connection and collaboration across the stars. And it could open up new possibilities for scientific discovery as researchers share data and insights in real time, no matter where they are in the universe. As we continue to explore the mysteries of dark matter, the idea of using it to create interstellar communication networks becomes increasingly compelling. While the road ahead is filled with challenges, the potential to revolutionize how we connect across the cosmos is too exciting to ignore. Next, we'll explore how dark matter could be used to manipulate time itself, potentially allowing astronauts to experience less time during long space journeys. Stay tuned as we uncover this next fascinating possibility. Now, let's shift our focus to a concept that could redefine the very experience of time during space travel: dark matter as a tool for manipulating time dilation. Imagine embarking on a journey to a distant star system, only to arrive feeling as though mere months have passed while decades have gone by on Earth. This mind-bending possibility hinges on the idea that dark matter could be used to influence the flow of time itself, offering a revolutionary solution to one of the greatest challenges of interstellar travel. At the core of this theory is the principle of time dilation, a phenomenon predicted by Einstein's theory of relativity. Time dilation occurs when an object moves at extremely high speeds or is subjected to intense gravitational forces, causing time to pass more slowly for that object compared to a stationary observer. For astronauts traveling at near light speeds or near massive objects, this means they could experience time differently than those on Earth. Dark matter, with its immense gravitational influence, could potentially amplify or control this effect, allowing us to manipulate time dilation to our advantage. One intriguing possibility is using dark matter to create localized regions of intense gravitational fields around a spacecraft. By concentrating dark matter in specific areas, we could generate a gravitational bubble that slows down time for those inside it. This would mean that astronauts could travel vast distances while experiencing significantly less time passing for them compared to the outside universe. For example, a journey that takes 50 years from Earth's perspective might feel like only 5 years for the crew, drastically reducing the psychological and physical toll of long-duration missions. Another approach involves leveraging dark matter's gravitational effects to create a time warp around a spacecraft. By carefully manipulating the distribution of dark matter, we could create a space-time curvature that effectively compresses time for the travelers. This would not only make interstellar travel more feasible, but also open up new possibilities for exploring the far reaches of the galaxy without the constraints of aging or resource limitations. Of course, the challenges are immense. Manipulating dark matter to such a precise degree would require breakthroughs in both physics and engineering. We would need to develop technologies capable of detecting, isolating, and controlling dark matter in ways that are currently beyond our reach. Additionally, the ethical implications of time dilation, such as the disconnect between travelers and those they leave behind, would need to be carefully considered. Despite these hurdles, the potential benefits are staggering. By using dark matter as a time dilation tool, we could make interstellar travel more practical and sustainable, enabling humanity to explore distant star systems without sacrificing decades of life. It could also pave the way for new scientific discoveries, as researchers gain the ability to study the effects of extreme time dilation in controlled environments. As we continue to unravel the mysteries of dark matter, the idea of using it to manipulate time becomes an increasingly tantalizing possibility. While the road ahead is filled with challenges, the potential to transform our understanding of time and space is too compelling to ignore. Next, we'll explore how dark matter could be used to generate artificial gravity on spacecraft, improving the health and comfort of astronauts during long missions. Stay tuned as we uncover this next groundbreaking theory. Now, let's turn our attention to a concept that could revolutionize life aboard spacecraft: artificial gravity powered by dark matter. Imagine floating through a spaceship weightless and free, but also facing the long-term health risks that come with prolonged exposure to zero gravity. Muscle atrophy, bone density loss, and even vision problems are just some of the challenges astronauts face during extended missions. But what if dark matter could provide a solution, creating artificial gravity to keep astronauts healthy and comfortable on their journey through the cosmos? The idea of artificial gravity isn't new. Science fiction has long imagined spinning space stations or rotating spacecraft to simulate gravity through centrifugal force. But dark matter offers a more elegant and potentially more effective solution. By harnessing the gravitational properties of dark matter, we could create a stable, controllable gravitational field inside a spacecraft, mimicking the conditions of Earth's gravity without the need for complex mechanical systems. Here's how it could work. Dark matter, with its immense gravitational influence, could be concentrated in specific areas around or within a spacecraft. By carefully manipulating its distribution, we could generate a gravitational pull that mimics Earth's gravity. This would allow astronauts to walk, eat, and sleep as they would on Earth, reducing the physical strain of zero gravity and improving their overall well-being during long missions. One approach involves creating a dark matter core within the spacecraft. This core would act as a gravitational anchor, pulling everything toward it and creating a consistent downward force. The intensity of this force could be adjusted depending on the mission's needs, allowing for partial gravity in some areas or full Earth-like gravity in others. This flexibility would be invaluable for both crew comfort and scientific experiments that require specific gravitational conditions. Another possibility is using dark matter to create localized gravitational fields within different sections of the spacecraft. For example, the living quarters could have Earth-like gravity, while the laboratory or storage areas could remain in microgravity. This would allow astronauts to switch between environments as needed, combining the benefits of artificial gravity with the unique opportunities of weightlessness. Of course, the challenges are significant. Manipulating dark matter to create precise gravitational fields would require a deep understanding of its properties and behavior. We would need advanced technologies to detect, isolate, and control dark matter in ways that are currently beyond our capabilities. Additionally, the energy requirements for such a system could be substantial, raising questions about feasibility and sustainability. Despite these hurdles, the potential benefits are immense. Artificial gravity powered by dark matter could transform long-duration space missions, making them safer and more comfortable for astronauts. It could also open up new possibilities for space exploration, enabling missions to distant planets or even other star systems without the health risks associated with zero gravity. As we continue to explore the mysteries of dark matter, the idea of using it to generate artificial gravity becomes an exciting frontier in space travel. While the road ahead is filled with challenges, the potential to improve the lives of astronauts and expand our reach into the cosmos is too compelling to ignore. Next, we'll delve into how dark matter's distribution in the universe could serve as a cosmic map, guiding spacecraft through the vast expanse of space. Stay tuned as we uncover this next groundbreaking theory. Now, let's shift our focus to a theory that could redefine how we navigate the vastness of space using dark matter as a cosmic map. Imagine setting out on a journey across an uncharted ocean without a compass or stars to guide you. That's the challenge spacecraft face when traveling through the cosmos. But what if the invisible web of dark matter that permeates the universe could act as a guide, helping us chart a course through the stars? Dark matter's gravitational influence shapes the structure of the universe, creating vast networks of filaments and clusters that span billions of light years. These structures, often referred to as the cosmic web, are like the highways of the universe connecting galaxies and other celestial bodies. By mapping the distribution of dark matter, we could identify these gravitational pathways, providing a natural navigation system for spacecraft. Here's how it might work. Spacecraft equipped with advanced sensors could detect the gravitational signatures of dark matter, allowing them to pinpoint their location relative to these cosmic landmarks. Think of it as a galactic GPS where dark matter acts as the reference points. By following the gravitational contours of the cosmic web, spacecraft could plot efficient routes through space, avoiding obstacles and reducing travel time. One of the most exciting possibilities is using dark matter maps to locate gravitational shortcuts. Just as a hiker might use a mountain pass to cross a range more quickly, spacecraft could use areas where dark matter's gravitational pull creates natural pathways or slingshot effects. These shortcuts could significantly reduce the energy and time required for interstellar travel, making distant star systems more accessible. Another advantage of using dark matter as a cosmic map is its stability. Unlike stars or planets, which move and change over time, dark matter's distribution remains relatively constant on cosmic timescales. This means that once we map these gravitational pathways, they could serve as reliable navigation tools for centuries, providing a consistent framework for space exploration. Of course, there are challenges to overcome. Mapping dark matter with the precision needed for navigation would require unprecedented advancements in detection technology. We'd need sensors capable of measuring the subtle gravitational effects of dark matter across vast distances. Additionally, interpreting this data in real time would demand sophisticated algorithms and computing power, pushing the boundaries of our current capabilities. Despite these hurdles, the potential is staggering. A dark matter-based navigation system could revolutionize space travel, enabling missions to distant galaxies with greater accuracy and efficiency. It could also open up new possibilities for exploration, allowing us to venture into regions of the universe that were previously beyond our reach. As we continue to unravel the mysteries of dark matter, the idea of using it as a cosmic map becomes an increasingly compelling vision for the future of space travel. While the journey to harness this technology is long, the rewards navigating the cosmos with the precision of a cosmic cartographer are worth the effort. Next, we'll explore how dark matter could enhance quantum computing, unlocking new possibilities for space exploration and beyond. Stay tuned as we dive into this next fascinating theory. Now, let's venture into a realm where the invisible meets the unimaginable: dark matter as a quantum computing resource. Quantum computing is already poised to revolutionize technology, but what if dark matter could take it to the next level, unlocking unprecedented capabilities for space travel and navigation? Quantum computers rely on qubits, which can exist in multiple states simultaneously, allowing them to perform complex calculations far beyond the reach of traditional computers. However, maintaining the stability of qubits is a significant challenge, as they are highly sensitive to external interference. This is where dark matter could play a transformative role. Dark matter's unique properties, such as its weak interactions with ordinary matter, could provide an ideal environment for quantum computing. Imagine using dark matter particles to shield qubits from external disturbances, creating a stable and isolated system for quantum operations. This could drastically reduce errors and improve the reliability of quantum calculations, making them more practical for real-world applications. But the potential doesn't stop there. Dark matter's gravitational influence could also be harnessed to manipulate qubits in ways we've never thought possible. For instance, the subtle gravitational effects of dark matter could be used to fine-tune the alignment of qubits, enhancing their coherence and performance. This could lead to quantum computers capable of solving problems that are currently beyond our reach, such as optimizing interstellar travel routes or simulating the behavior of dark matter itself. One of the most exciting possibilities is using dark matter-enhanced quantum computing to process the vast amounts of data required for space navigation. As we discussed earlier, mapping dark matter's gravitational pathways could provide a cosmic GPS for spacecraft, but interpreting this data in real time would require immense computational power. Quantum computers boosted by dark matter could handle this task with ease, enabling spacecraft to navigate the cosmos with unparalleled precision. Additionally, dark matter could help us develop new algorithms specifically designed for quantum systems. These algorithms could unlock new ways to analyze gravitational data, predict cosmic phenomena, and even design advanced propulsion systems. The synergy between dark matter and quantum computing could open up entirely new avenues for space exploration, making the impossible seem within reach. Of course, there are significant challenges to overcome. Harnessing dark matter for quantum computing would require breakthroughs in both fields, from detecting and manipulating dark matter particles to developing new quantum technologies. But the potential rewards are immense. By combining the mysteries of dark matter with the power of quantum computing, we could unlock a new era of space exploration where the stars are no longer out of reach. As we continue to explore the possibilities, the idea of dark matter as a quantum computing resource becomes a tantalizing glimpse into the future. It's a reminder that the universe holds secrets we've only begun to uncover, and that the key to unlocking them might lie in the very fabric of the cosmos. Next, we'll delve into how dark matter could serve as a cosmic anchor, providing stability for spacecraft in the vastness of space. Stay tuned as we uncover this next groundbreaking theory. Now, let's shift our focus to a concept that could redefine how spacecraft maintain their position in the vast expanse of space: dark matter as a cosmic anchor. Imagine a scenario where a spacecraft needs to remain perfectly still, whether for scientific observations, repairs, or even docking with another vessel. In the vacuum of space, where there's no solid ground or atmosphere to provide resistance, maintaining stability is a significant challenge. This is where dark matter could offer a groundbreaking solution. Dark matter's gravitational influence, though subtle, is omnipresent throughout the universe. By harnessing this influence, we could create a system that allows spacecraft to anchor themselves in place, effectively preventing drift. Think of it as an invisible tether, one that doesn't rely on physical materials but instead uses the gravitational pull of dark matter to hold a spacecraft steady. This could be especially useful in regions of space where traditional methods of stabilization, like thrusters or gyroscopes, are either inefficient or impractical. One potential application of this theory is in deep space observatories. These observatories require extreme precision to capture clear images of distant stars and galaxies. Even the slightest movement can distort the data. By using dark matter as an anchor, we could ensure that these observatories remain perfectly still, allowing for unprecedented levels of accuracy in astronomical research. Similarly, spacecraft conducting delicate repairs or assembling structures in orbit could benefit from this technology, as it would eliminate the risk of unintended movement. But how exactly could we harness dark matter's gravitational pull for this purpose? One idea involves creating a device that interacts with dark matter particles, effectively locking the spacecraft into a specific position relative to the surrounding dark matter distribution. This device would need to detect and respond to the gravitational fluctuations caused by dark matter, adjusting its own gravitational field to maintain stability. While this technology is still purely theoretical, the principles behind it are rooted in our growing understanding of dark matter's behavior. Another intriguing possibility is using dark matter anchors to stabilize spacecraft during long-duration missions. For example, a spacecraft traveling to a distant star system might need to pause its journey to conduct repairs or gather resources. Without a stable anchor, the spacecraft could drift off course, making it difficult to resume its trajectory. A dark matter-based anchoring system could provide the stability needed to ensure the mission stays on track. Of course, there are challenges to overcome. Detecting and interacting with dark matter remains one of the greatest mysteries in modern physics. Developing a device capable of harnessing its gravitational influence would require breakthroughs in both dark matter research and gravitational engineering. However, the potential benefits are immense. By turning dark matter into a cosmic anchor, we could unlock new possibilities for space exploration, making it safer, more precise, and more efficient. As we continue to explore the mysteries of dark matter, the idea of using it as a cosmic anchor offers a glimpse into a future where the invisible forces of the universe become tools for human ingenuity. It's a reminder that even the most elusive elements of the cosmos could hold the key to solving some of our greatest challenges in space travel. Next, we'll dive into how dark matter could act as a radiation absorber, protecting astronauts and spacecraft from the dangers of cosmic radiation. Stay with us as we uncover this next fascinating theory. Now, let's turn our attention to another groundbreaking application of dark matter: its potential to act as a cosmic shield against harmful radiation. As we venture deeper into space, one of the most significant threats to astronauts and spacecraft is the constant bombardment of cosmic radiation. This invisible danger, composed of high-energy particles from the sun and distant stars, can damage equipment, disrupt electronics, and pose serious health risks to crew members. But what if dark matter could provide a solution? Imagine a spacecraft equipped with a dark matter-based radiation shield. Unlike traditional shielding materials, which are often heavy and bulky, dark matter's unique properties could offer a lightweight and efficient alternative. By interacting with dark matter particles, we might create a barrier that absorbs or deflects harmful radiation, effectively protecting the spacecraft and its occupants. This could be a game-changer for long-duration missions, where prolonged exposure to cosmic radiation is a major concern. One of the key advantages of using dark matter as a radiation absorber lies in its omnipresence. Dark matter is everywhere, permeating the universe in vast, invisible clouds. If we could harness its ability to interact with radiation, we could create a shield that adapts to the intensity of cosmic rays, providing dynamic protection as the spacecraft travels through different regions of space. This adaptability would be especially valuable in areas with high radiation levels, such as near the Sun or in the vicinity of neutron stars. But how might this work in practice? One theory suggests that dark matter particles could absorb the energy from cosmic radiation, converting it into a harmless form of energy or dispersing it safely. Another idea involves using dark matter to create a gravitational field that deflects radiation away from the spacecraft. Both approaches rely on our ability to detect and manipulate dark matter, which remains a significant scientific challenge. However, advancements in particle physics and gravitational engineering could one day make this a reality. The implications of this technology are profound. For astronauts, it could mean safer journeys to distant planets and beyond, reducing the risk of radiation-induced illnesses. For spacecraft, it could extend mission lifespans by protecting sensitive electronics from damage. Even unmanned probes could benefit, as they often carry delicate instruments that are vulnerable to radiation. Of course, there are hurdles to overcome. Detecting dark matter and understanding its interactions with radiation is no small feat. Current experiments, like those conducted in underground laboratories, are only beginning to scratch the surface of dark matter's behavior. But as our knowledge grows, so too does the potential to turn this mysterious substance into a powerful tool for space exploration. By envisioning dark matter as a radiation absorber, we open the door to a future where the dangers of cosmic radiation are no longer a barrier to human exploration. It's a reminder that the universe's most elusive elements might hold the key to overcoming its greatest challenges. Next, we'll explore how dark matter could stabilize space-time around spacecraft, preventing disruptions caused by extreme gravitational forces. Stay tuned as we uncover this next fascinating theory. Now, let's shift our focus to another fascinating possibility: dark matter as a space-time stabilizer. As spacecraft venture into the depths of space, they often encounter extreme gravitational forces, such as those near black holes or massive celestial bodies. These forces can distort space-time, creating chaotic conditions that disrupt navigation, damage equipment, and even endanger the crew. But what if dark matter could act as a stabilizing force, smoothing out these distortions and ensuring a safer journey? Picture this: a spacecraft equipped with a dark matter-based stabilization system. Unlike traditional methods that rely on heavy shielding or complex propulsion adjustments, this system would use dark matter's unique gravitational properties to counteract the effects of extreme space-time distortions. By interacting with dark matter, the spacecraft could create a stable bubble of space-time around itself, effectively neutralizing the disruptive forces it encounters. One of the most intriguing aspects of this theory is dark matter's ability to influence gravity without being directly visible. Dark matter's gravitational pull could be harnessed to balance out the intense forces exerted by massive objects, creating a more uniform and predictable environment for the spacecraft. This would not only protect the vessel and its occupants, but also allow for more precise navigation through regions of space that are currently considered too hazardous to explore. How might this work in practice? One idea involves using dark matter to generate a localized gravitational field that counteracts the distortions caused by nearby massive objects. Another approach suggests that dark matter could be used to anchor the spacecraft in a stable region of space-time, preventing it from being pulled into chaotic gravitational fields. Both concepts rely on our ability to detect and manipulate dark matter, which remains a significant scientific challenge. However, advancements in gravitational physics and dark matter research could one day make these ideas a reality. The implications of this technology are immense. For deep space missions, it could mean safer travel through regions previously deemed too dangerous, such as the vicinity of black holes or neutron stars. It could also extend the lifespan of spacecraft by protecting them from the wear and tear caused by extreme gravitational forces. Even unmanned probes could benefit, as they often carry delicate instruments that are vulnerable to space-time distortions. Of course, there are challenges to overcome. Understanding how dark matter interacts with space-time and developing the technology to harness its stabilizing effects will require groundbreaking research. But as our knowledge of dark matter grows, so too does the potential to turn this mysterious substance into a powerful tool for space exploration. By envisioning dark matter as a space-time stabilizer, we open the door to a future where the dangers of extreme gravitational forces are no longer a barrier to human exploration. It's a reminder that the universe's most elusive elements might hold the key to overcoming its greatest challenges. Next, we'll explore how dark matter could be used to refine and produce fuel for spacecraft during long journeys. Stay tuned as we uncover this next groundbreaking theory. Now, let's venture into another groundbreaking idea: dark matter as a cosmic fuel refinery. Imagine a future where spacecraft no longer rely solely on traditional fuel sources, which are heavy, limited, and require frequent resupply. Instead, they could harness dark matter to refine and produce fuel on the go, enabling longer, more efficient missions into the depths of space. The concept revolves around dark matter's unique properties. While we still don't fully understand its composition, scientists theorize that dark matter could interact with other forms of matter or energy in ways that release vast amounts of power. If we could tap into these interactions, dark matter might serve as a virtually limitless fuel source, capable of sustaining spacecraft for decades or even centuries. Here's how it might work. A spacecraft equipped with a dark matter refinery system could collect dark matter particles as it travels through space. These particles would then be processed, either through direct conversion into energy or by catalyzing reactions with other materials to produce usable fuel. Unlike conventional fuels, which require storage tanks and careful management, dark matter-based fuel systems could operate continuously, drawing energy from the invisible fabric of the universe itself. One of the most exciting possibilities is the idea of self-sustaining spacecraft. By refining dark matter into fuel, a vessel could theoretically generate its own power supply without needing to return to Earth or rely on external resources. This would be a game-changer for deep space exploration, allowing missions to travel farther and last longer than ever before. Imagine probes venturing to the farthest reaches of the galaxy, powered entirely by dark matter, or crewed missions to distant star systems without the need for massive fuel reserves. Of course, there are significant challenges to overcome. Detecting and capturing dark matter remains one of the biggest hurdles, as does understanding how to safely and efficiently convert it into usable energy. Current technology is far from capable of achieving this, but ongoing research into dark matter's properties and interactions could pave the way for breakthroughs in the coming decades. The potential benefits are immense. Not only would dark matter fuel systems reduce the weight and complexity of spacecraft, but they could also eliminate the need for risky refueling missions or the construction of massive fuel depots in space. This would make interstellar travel more practical and cost-effective, opening up new possibilities for exploration and discovery. By envisioning dark matter as a cosmic fuel refinery, we unlock a future where the limitations of traditional fuel are a thing of the past. It's a bold idea, but one that could revolutionize how we explore the universe. Next, we'll dive into how dark matter could be used to cool spacecraft systems, ensuring they remain operational during extended missions. Stay tuned as we uncover this next fascinating theory. Now, let's shift our focus to a critical challenge in space travel: keeping spacecraft systems cool during long missions. Overheating is a major concern for any spacecraft, especially those venturing into the harsh environment of deep space. Traditional cooling methods like radiators and heat exchangers are effective but come with limitations such as added weight and energy consumption. This is where dark matter could offer a revolutionary solution. Imagine a spacecraft equipped with a dark matter-based cooling system. Unlike conventional methods, which rely on physical materials to absorb and dissipate heat, a dark matter cooling system could leverage the unique properties of dark matter to regulate temperature in a completely new way. Scientists theorize that dark matter particles, which barely interact with ordinary matter, could be used to absorb excess heat without adding significant mass to the spacecraft. This would make the system incredibly efficient, allowing for longer missions without the risk of overheating. Here's how it might work. Dark matter particles could be directed to absorb thermal energy from critical systems, such as engines, electronics, or life support. Because dark matter doesn't interact strongly with normal matter, it could carry this heat away without transferring it back to the spacecraft. The absorbed heat could then be radiated into space, effectively cooling the systems without the need for bulky cooling equipment. This process could be continuous, ensuring that the spacecraft remains at an optimal temperature even during the most demanding operations. One of the most exciting aspects of this theory is its potential to reduce the size and weight of spacecraft. Traditional cooling systems often require large radiators or heat sinks, which take up valuable space and add to the overall mass of the vessel. A dark matter cooling system, on the other hand, could be compact and lightweight, freeing up resources for other critical components. This would make spacecraft more agile and efficient, enabling them to travel farther and faster than ever before. Of course, there are significant challenges to overcome. Detecting and manipulating dark matter remains a major hurdle, as does understanding how to harness its properties for practical applications like cooling. Current technology is far from capable of achieving this, but ongoing research into dark matter's behavior and interactions could bring us closer to making this idea a reality. The potential benefits are immense. A dark matter cooling system could extend the lifespan of spacecraft, reduce the risk of system failures, and enable missions to explore regions of space that were previously too hazardous due to extreme temperatures. It's a bold concept, but one that could transform the way we design and operate spacecraft in the future. By envisioning dark matter as a cooling system, we open up new possibilities for space exploration. It's a reminder that even the most mysterious elements of the universe could hold the key to solving some of our greatest challenges. Next, we'll explore how dark matter could be used to create a cosmic tractor beam, offering a new way to manipulate objects in space. Stay tuned as we uncover this next fascinating theory. Now, let's venture into a concept that sounds like it's straight out of science fiction, but could one day become a reality: dark matter as a cosmic tractor beam. Imagine being able to move objects in space without physical contact, using nothing but the invisible force of dark matter. This idea takes inspiration from the gravitational pull of dark matter, which could potentially be harnessed to manipulate objects across vast distances. The concept of a tractor beam has long been a staple of futuristic stories, but dark matter might offer a way to make it work in real life. Dark matter's gravitational influence is one of its most defining characteristics, and scientists believe it could be used to create a controlled gravitational field. This field could act like a tractor beam, pulling or pushing objects in space without the need for traditional propulsion methods. For example, a spacecraft equipped with a dark matter tractor beam could redirect asteroids, capture debris, or even assist in docking procedures with other vessels. Here's how it might function: by generating a localized gravitational field using dark matter particles, a spacecraft could create a pull or push effect on nearby objects. Since dark matter interacts gravitationally but not electromagnetically, it could manipulate objects without the risk of damaging them through physical contact. This would be especially useful in delicate operations, such as retrieving samples from distant planets or moving hazardous materials in space. One of the most exciting applications of this technology would be in planetary defense. Imagine being able to deflect an asteroid on a collision course with Earth by using a dark matter tractor beam to alter its trajectory. This could provide a non-invasive and highly precise method of protecting our planet from potential threats. Additionally, such a system could revolutionize space construction, allowing for the assembly of large structures like space stations or satellites without the need for complex mechanical systems. Of course, there are significant challenges to overcome. Harnessing dark matter's gravitational pull requires a deep understanding of its behavior and the ability to manipulate it on a practical scale. Current technology is far from achieving this, but advancements in dark matter research could pave the way for such innovations. Scientists are already exploring ways to detect and interact with dark matter, and these efforts could eventually lead to the development of a cosmic tractor beam. The potential benefits of this technology are immense. It could make space exploration safer, more efficient, and more versatile, opening up new possibilities for missions that were previously too risky or impractical. By envisioning dark matter as a tool for manipulating objects in space, we're taking a bold step toward a future where the invisible forces of the universe become our allies in exploration. As we continue to explore the possibilities of dark matter, let's turn our attention to another groundbreaking idea: using dark matter to compress space-time, potentially reducing travel time between distant star systems. Stay with us as we dive into this next fascinating theory. Now, let's shift our focus to a concept that could redefine how we think about interstellar travel: dark matter as a space-time compressor. Imagine being able to shrink the vast distances between star systems, making journeys that once took centuries achievable in a fraction of the time. This idea hinges on the ability to manipulate space-time itself, and dark matter might just hold the key to making it possible. The concept of compressing space-time is rooted in the principles of general relativity, which describe how massive objects can warp the fabric of the universe. Dark matter, with its immense gravitational influence, could theoretically be used to create localized distortions in space-time. By concentrating dark matter in specific regions, we might be able to create a shortcut through space, effectively reducing the distance between 2 points. Here's how it could work. A spacecraft equipped with a dark matter-based system could generate a controlled gravitational field, compressing the space-time in front of it while expanding it behind. This would create a kind of warp bubble that allows the spacecraft to travel through space at speeds that appear faster than light, without actually breaking the laws of physics. The result: a dramatic reduction in travel time between distant star systems. One of the most exciting applications of this technology would be in interstellar exploration. Imagine sending a probe to Alpha Centauri, our nearest star system, and having it arrive in just a few years instead of the tens of thousands it would take with current propulsion methods. This could open up entirely new possibilities for studying exoplanets, searching for extraterrestrial life, and even establishing human colonies in other star systems. But the potential doesn't stop there. A space-time compressor could also revolutionize our understanding of the universe. By making distant regions of space more accessible, we could gather data and conduct experiments that were previously impossible. This could lead to breakthroughs in our understanding of dark matter, dark energy, and the fundamental nature of the cosmos. Of course, there are significant challenges to overcome. Manipulating space-time on such a scale requires an unprecedented level of control over dark matter, something we're still far from achieving. Current research is focused on detecting and understanding dark matter, but the idea of using it to compress space-time remains largely theoretical. However, as our knowledge grows, so too does the possibility of turning this science fiction into science fact. The implications of this technology are staggering. It could transform space travel from a slow, arduous process into a fast, efficient endeavor, bringing the stars within our reach. By exploring the potential of dark matter as a space-time compressor, we're not just imagining a future of faster travel, we're envisioning a future where the universe itself becomes our highway. As we continue to push the boundaries of what's possible, let's turn our attention to another intriguing idea using dark matter as a cosmic energy converter, potentially unlocking new sources of power for spacecraft. Stay with us as we explore this next fascinating theory. Now, let's explore another groundbreaking idea that could revolutionize how we power spacecraft: dark matter as a cosmic energy converter. Picture this, a spacecraft that doesn't rely on traditional fuel sources like chemical rockets or solar panels, but instead taps into the vast, untapped energy of the cosmos itself. This concept revolves around harnessing the interactions of dark matter particles to generate usable energy, potentially providing an almost limitless power source for long-duration missions. The key to this theory lies in the unique properties of dark matter. While we still don't fully understand its nature, we know it interacts gravitationally and, in some models, may interact weakly with other particles. These interactions could theoretically be exploited to convert dark matter's energy into a form that spacecraft can use. Imagine a system that captures dark matter particles as they pass through space, then triggers controlled reactions to release their energy. This energy could be used to power propulsion systems, life support, and onboard instruments, enabling spacecraft to operate far beyond the reach of traditional power sources. One of the most exciting aspects of this idea is its potential to overcome one of the biggest challenges in space travel: energy limitations. Current spacecraft rely on finite resources like fuel or solar energy, which become less effective as missions venture farther from the sun. A dark matter-based energy converter, however, could provide a consistent and abundant power supply, even in the darkest reaches of interstellar space. This would make it possible to explore regions of the universe that are currently beyond our reach, such as the outer edges of our galaxy or even neighboring galaxies. But how might this work in practice? One possibility is a device that uses dark matter's gravitational influence to generate energy. For example, as dark matter particles pass through a spacecraft, their gravitational pull could be harnessed to drive a generator, converting their motion into electricity. Another approach could involve using dark matter's weak interactions with ordinary matter to trigger energy-releasing reactions, similar to how nuclear reactions release energy from atoms. While these ideas are still in the realm of theory, they represent a tantalizing glimpse into what might be possible. The implications of this technology are profound. A spacecraft powered by dark matter could operate indefinitely, traveling vast distances without the need for refueling or recharging. This would open up new possibilities for exploration, from studying distant star systems to searching for signs of life on exoplanets. It could also enable missions to carry more advanced scientific instruments, as the energy constraints that currently limit their capabilities would no longer apply. Of course, there are significant hurdles to overcome. Detecting and interacting with dark matter remains a major challenge, and we're still far from understanding how to harness its energy. However, as research into dark matter continues, the possibility of using it as a cosmic energy converter becomes increasingly plausible. This idea represents not just a new way to power spacecraft, but a new way to think about energy itself, one that could transform our understanding of the universe and our place within it. As we continue to push the boundaries of what's possible, let's turn our attention to another fascinating concept: using dark matter as a spacecraft repair tool, potentially extending mission durations and ensuring the survival of astronauts in the harsh environment of space. Stay with us as we dive into this next intriguing theory. Now, let's shift our focus to a concept that could redefine how we maintain and repair spacecraft during long missions: dark matter as a spacecraft repair tool. Imagine a scenario where a spacecraft traveling through the depths of space encounters a critical system failure. Traditional repair methods might be limited by the availability of spare parts or the ability to send help from Earth. But what if dark matter could provide a solution, enabling self-repairing systems that keep missions running smoothly, even in the most remote corners of the universe. The idea here is to harness the unique properties of dark matter to create a repair mechanism that operates on a fundamental level. Dark matter's gravitational influence and potential interactions with ordinary matter could be used to manipulate materials at the atomic or subatomic scale. For instance, a spacecraft equipped with a dark matter-based repair system might use the particles to realign damaged components, fill in microscopic cracks, or even regenerate critical materials. This could be achieved by directing dark matter's energy to stimulate molecular bonds or rearrange structures, effectively healing the spacecraft over time. One of the most compelling aspects of this theory is its potential to extend mission duration significantly. Currently, spacecraft are limited by the wear and tear of their systems, which can degrade over time due to radiation, micrometeoroid impacts, or mechanical stress. A dark matter repair tool could counteract these effects, ensuring that critical systems remain functional for much longer than currently possible. This would be especially valuable for missions to distant destinations, where the ability to repair and maintain equipment could mean the difference between success and failure. But how might this work in practice? One possibility is a system that uses dark matter's gravitational pull to manipulate materials at a microscopic level. For example, if a spacecraft's hull develops a crack, dark matter particles could be directed to the affected area, using their gravitational influence to pull the material back together. Another approach could involve using dark matter's weak interactions to trigger chemical reactions that repair damaged components, such as reconnecting broken circuits or reinforcing weakened structures. While these ideas are still speculative, they offer a glimpse into a future where spacecraft are not only self-sustaining but also self-repairing. The implications of this technology are profound. A spacecraft capable of repairing itself using dark matter could operate for decades, if not centuries, without needing external assistance. This would open up new possibilities for exploration, enabling missions to travel farther and last longer than ever before. It could also reduce the risks faced by astronauts, as the ability to repair critical systems in real time would enhance their safety and the overall reliability of the mission. Of course, there are significant challenges to overcome. Detecting and manipulating dark matter remains a major hurdle, and we're still far from understanding how to harness its properties for practical applications. However, as research into dark matter continues, the possibility of using it as a repair tool becomes increasingly intriguing. This idea represents not just a new way to maintain spacecraft, but a new way to think about resilience and sustainability in space exploration. As we continue to explore the potential of dark matter, let's turn our attention to another fascinating concept: using dark matter as a cosmic speed booster, potentially propelling spacecraft to unprecedented velocities and reducing travel time to distant stars. Stay with us as we dive into this next groundbreaking theory. Now, let's venture into a concept that could revolutionize how we think about speed in space travel: dark matter as a cosmic speed booster. Picture this: a spacecraft equipped with a propulsion system that doesn't rely on traditional fuel, but instead taps into the mysterious properties of dark matter to achieve velocities far beyond what we've ever imagined. This idea isn't just about going faster, it's about redefining the limits of human exploration and shrinking the vast distances between stars. The core of this theory lies in dark matter's gravitational influence. Unlike ordinary matter, dark matter doesn't interact with light or electromagnetic forces, but its gravitational pull is immense. Scientists speculate that if we could somehow harness this gravitational force, we might be able to create a propulsion system that accelerates spacecraft to speeds previously thought impossible. Imagine a spacecraft being pulled forward by the gravitational attraction of dark matter, effectively surfing on the invisible fabric of the universe. One approach to achieving this could involve creating a dark matter sail. Similar to how solar sails use the pressure of sunlight to propel spacecraft, a dark matter sail would use the gravitational pull of dark matter particles to generate thrust. By positioning the sail in regions of space with high concentrations of dark matter, the spacecraft could continuously accelerate, reaching speeds that would make interstellar travel feasible within a human lifetime. This method would eliminate the need for carrying massive amounts of fuel, as the energy would come directly from the dark matter itself. Another intriguing possibility is the use of dark matter to create a gravitational slingshot effect. Just as spacecraft currently use the gravity of planets to gain speed, a dark matter-based system could use the gravitational fields of dark matter clusters to propel spacecraft to incredible velocities. This would require precise navigation and mapping of dark matter distributions in space, but the payoff could be transformative. A single slingshot maneuver around a dark matter cluster might accelerate a spacecraft to a significant fraction of the speed of light, drastically reducing travel time to distant star systems. The implications of this technology are staggering. With dark matter as a speed booster, missions to Alpha Centauri, our nearest star system, could take just a few decades instead of tens of thousands of years. This would open up the possibility of sending probes or even crewed missions to explore exoplanets and search for signs of life beyond our solar system. It could also enable the establishment of interstellar trade routes connecting human colonies across the galaxy. However, there are significant challenges to overcome. Detecting and interacting with dark matter remains one of the greatest mysteries in modern physics. We don't yet know how to manipulate dark matter's gravitational effects or how to build a propulsion system that can harness its power. But as our understanding of dark matter grows, so too does the potential for turning this theory into reality. The idea of using dark matter as a cosmic speed booster represents a bold leap forward in our quest to explore the cosmos. As we continue to push the boundaries of what's possible, let's turn our attention to another groundbreaking concept using dark matter to expand space-time itself, creating pathways for faster interstellar travel. Stay with us as we explore this next fascinating theory. Now, let's shift our focus to a concept that could fundamentally alter our understanding of space and time: dark matter as a space-time expander. Imagine a universe where the very fabric of space-time isn't fixed but can be stretched and manipulated to create shortcuts through the cosmos. This idea isn't just about moving faster. It's about reshaping the structure of space itself to make interstellar travel more efficient and accessible. At the heart of this theory is the idea that dark matter, with its immense gravitational influence, could be used to expand or warp space-time. In Einstein's theory of general relativity, massive objects like stars and planets bend space-time, creating what we perceive as gravity. Dark matter, being far more abundant and widespread than ordinary matter, could potentially exert an even greater influence on the curvature of space-time. If we could harness this effect, we might be able to create localized expansions or bubbles of space-time that act as shortcuts between distant points in the universe. One way this could work is by using dark matter to generate a controlled expansion of space-time around a spacecraft. By creating a region of expanded space-time behind the spacecraft and a contracted region in front of it, the vessel could effectively ride the wave of expanded space, moving faster than the speed of light without actually breaking the laws of physics. This concept is similar to the idea of a warp drive, but instead of relying on exotic matter or energy, it leverages the natural properties of dark matter to achieve the same effect. Another possibility involves using dark matter to create stable wormholes, hypothetical tunnels through space-time that connect two distant points. While the existence of wormholes remains theoretical, dark matter's gravitational effects could provide the necessary energy to stabilize these structures, making them viable for interstellar travel. By entering one end of a wormhole and exiting the other, a spacecraft could traverse vast distances in an instant, bypassing the need for traditional propulsion altogether. The implications of this technology are profound. If we could expand space-time using dark matter, the journey to distant star systems could be reduced from thousands of years to mere months or even days. This would not only make interstellar exploration feasible, but could also pave the way for the establishment of interstellar colonies and the exchange of resources and knowledge across the galaxy. However, the challenges are immense. Manipulating space-time requires an understanding of dark matter that we currently lack. We don't yet know how to generate or control the gravitational fields needed to expand space-time, nor do we have the technology to create stable wormholes. But as our knowledge of dark matter grows, so too does the potential for turning these ideas into reality. The concept of using dark matter as a space-time expander represents a bold step toward unlocking the secrets of the universe and redefining the limits of human exploration. As we continue to explore the possibilities of dark matter, let's turn our attention to another fascinating theory using dark matter as a cosmic energy storage system, providing a reliable power source for spacecraft on long missions. Stay with us as we delve into this next groundbreaking idea. Now, let's explore a concept that could revolutionize how we power our journeys through the cosmos: dark matter as a cosmic energy storage system. Imagine a future where spacecraft no longer rely on finite fuel sources like chemical propellants or solar energy. Instead, they tap into the immense energy potential of dark matter, unlocking a nearly limitless power supply for long-duration missions. At the core of this theory is the idea that dark matter, with its mysterious and abundant presence, could act as a reservoir for storing vast amounts of energy. Unlike conventional energy sources, which degrade over time or require constant replenishment, dark matter's unique properties might allow it to hold energy indefinitely without loss. This could provide spacecraft with a consistent and reliable power source, even on missions that span decades or centuries. One way this could work is by harnessing the interactions between dark matter particles and ordinary matter. Scientists speculate that dark matter particles, though elusive, could release energy when they collide or interact in specific ways. If we could develop technology to capture and store this energy, it could be converted into usable power for propulsion, life support systems, and other critical functions aboard a spacecraft. The energy density of dark matter is thought to be extraordinarily high, meaning even a small amount could provide an enormous amount of power. Another intriguing possibility is using dark matter to create a kind of cosmic battery. By isolating and containing dark matter in a controlled environment, we might be able to extract energy from it as needed, much like charging and discharging a traditional battery. This would allow spacecraft to store energy during periods of low demand and release it during high-energy maneuvers, such as accelerating to escape a planet's gravity or navigating through hazardous regions of space. The implications of this technology are staggering. With dark matter as an energy source, spacecraft could travel farther and faster than ever before, unencumbered by the limitations of current power systems. Missions to the outer reaches of our solar system, or even to neighboring star systems, could become routine, opening up new frontiers for exploration and discovery. However, the challenges are significant. We still know very little about how dark matter interacts with ordinary matter, and developing the technology to harness its energy remains a distant goal. But as our understanding of dark matter deepens, the potential for creating a cosmic energy storage system becomes increasingly plausible. This theory represents not just a leap in space travel technology, but a fundamental shift in how we think about energy itself. As we continue to push the boundaries of what's possible, let's turn our attention to another groundbreaking idea: using dark matter as a spacecraft stealth system, making vessels invisible to detection. Stay with us as we uncover how this next theory could redefine the rules of space exploration. Now, let's shift our focus to a concept that sounds like it's straight out of science fiction: dark matter as a spacecraft stealth system. Imagine a future where spacecraft can move through the cosmos undetected, shielded from the prying eyes of advanced sensors or potential threats. This theory proposes that dark matter could be the key to creating such invisibility, revolutionizing not just space travel, but also the way we approach exploration and security in the universe. At the heart of this idea is the unique nature of dark matter itself. Unlike ordinary matter, dark matter doesn't interact with light or electromagnetic forces, making it effectively invisible to traditional detection methods. If we could somehow harness this property, we might be able to create a cloaking mechanism for spacecraft. By surrounding a vessel with a layer of dark matter, it could become invisible to radar, telescopes, and other detection systems that rely on electromagnetic signals. This would allow spacecraft to travel undetected, whether for scientific exploration, military purposes, or even to avoid collisions with space debris. One approach to achieving this could involve manipulating dark matter's gravitational effects. Since dark matter interacts primarily through gravity, it might be possible to use its gravitational influence to bend light around a spacecraft, effectively hiding it from view. This concept is similar to the idea of a gravitational lens, where massive objects like galaxies bend light, but on a much smaller and more controlled scale. If we could engineer a dark matter shield around a spacecraft, it could redirect light and other electromagnetic waves, rendering the vessel invisible to observers. Another possibility is using dark matter to absorb or neutralize the energy signatures that spacecraft emit. Every spacecraft generates heat, radiation, and other detectable signals as it operates. Dark matter, with its unique properties, might be able to absorb or dissipate these emissions, making the spacecraft blend seamlessly into the background of space. This would not only make it harder to detect, but also reduce the risk of being targeted by hostile forces or intercepted during sensitive missions. The implications of this technology are profound. A spacecraft equipped with a dark matter stealth system could explore uncharted regions of the universe without alerting potential adversaries or disturbing delicate cosmic environments. It could also enable covert missions to study alien civilizations or gather intelligence without detection. For military applications, this could provide a significant strategic advantage, allowing spacecraft to operate undetected in contested areas of space. However, the challenges are immense. We still don't fully understand how to manipulate dark matter, let alone contain it in a way that could be used for stealth purposes. The technology required to create such a system is far beyond our current capabilities, and it would require breakthroughs in both physics and engineering. But as our understanding of dark matter grows, so too does the possibility of turning this theory into reality. As we continue to explore the incredible potential of dark matter, let's turn our attention to another fascinating idea: using dark matter as a cosmic compass to navigate the vast expanse of the universe. Stay with us as we uncover how this next theory could guide us through the stars. Now, let's explore a concept that could redefine how we navigate the cosmos: dark matter as a cosmic compass. Imagine a future where spacecraft no longer rely solely on traditional navigation systems like GPS or star maps, but instead use the gravitational influence of dark matter to chart their course through the universe. This theory suggests that dark matter, with its pervasive and predictable gravitational effects, could serve as a natural guide for interstellar travel. At the core of this idea is the fact that dark matter is distributed throughout the universe in a web-like structure, creating gravitational landmarks that could be mapped and used for navigation. Unlike stars or planets, which move and change over time, dark matter's distribution is relatively stable, making it an ideal reference point for long-distance space travel. By detecting and analyzing the gravitational pull of dark matter, spacecraft could determine their position and trajectory with incredible precision, even in the vast emptiness of intergalactic space. One way this could work is by equipping spacecraft with advanced sensors capable of detecting the subtle gravitational signals emitted by dark matter. These sensors would measure the strength and direction of dark matter's gravitational influence, allowing the spacecraft to triangulate its position relative to known dark matter structures. This method would be especially useful in regions of space where traditional navigation tools like star maps are less effective due to the absence of visible landmarks. Another possibility is using dark matter's gravitational influence to create a kind of gravitational highway for spacecraft. Just as ancient sailors used ocean currents to navigate the seas, future spacecraft could follow the gravitational pathways created by dark matter to travel more efficiently through space. By aligning their trajectories with these pathways, spacecraft could reduce fuel consumption and travel time, making long-distance missions more feasible. The implications of this technology are profound. A dark matter-based navigation system could enable spacecraft to explore the farthest reaches of the universe with unprecedented accuracy. It could also provide a backup navigation method in case traditional systems fail, ensuring the safety of astronauts on long-duration missions. For missions to distant star systems or even other galaxies, this technology could be the key to successful navigation in uncharted territory. However, there are significant challenges to overcome. Detecting and mapping dark matter's gravitational influence with the precision required for navigation is no small feat. It would require advancements in sensor technology and a deeper understanding of dark matter's distribution and behavior. Additionally, creating a reliable navigation system based on dark matter would involve developing new algorithms and software to interpret the data collected by these sensors. As we continue to unlock the mysteries of dark matter, the idea of using it as a cosmic compass becomes increasingly compelling. It's a concept that could transform how we explore the universe, guiding us through the stars with the invisible hand of dark matter. Next, let's dive into how dark matter could stabilize spacecraft during extreme maneuvers, ensuring safe and controlled travel through the cosmos. Now, let's shift our focus to a theory that could revolutionize how spacecraft handle the unpredictable challenges of space travel: dark matter as a spacecraft stabilizer. Picture this: a spacecraft hurtling through the cosmos, navigating through intense gravitational fields or turbulent space environments. In such scenarios, maintaining stability is crucial, and dark matter might just hold the key to achieving it. The idea here is to harness the gravitational properties of dark matter to counteract the forces that destabilize spacecraft during extreme maneuvers. Dark matter's pervasive gravitational influence could act as a counterbalance, helping to steady a spacecraft as it accelerates, decelerates, or changes direction. This would be particularly useful in environments where traditional stabilization methods, like thrusters or gyroscopes, might struggle to keep up. One way this could work is by integrating dark matter-based systems into the spacecraft's design. These systems would detect and respond to gravitational fluctuations in real time, adjusting the spacecraft's orientation and trajectory to maintain stability. For example, if a spacecraft encounters a sudden gravitational pull from a nearby celestial body, the dark matter stabilizer could generate an opposing force to keep the craft on course. This would not only improve safety but also enhance the efficiency of space travel by reducing the need for constant manual adjustments. Another potential application is in turbulent regions of space, such as near black holes or in areas with intense cosmic radiation. In these environments, traditional stabilization systems can be overwhelmed by the extreme conditions. A dark matter stabilizer, however, could provide a steadying influence, allowing the spacecraft to navigate through these regions with greater control and precision. This would open up new possibilities for exploring some of the most challenging and scientifically intriguing parts of the universe. Of course, developing such a system is no small task. It would require a deep understanding of dark matter's behavior and the ability to manipulate its gravitational effects with precision. Advances in sensor technology and gravitational modeling would be essential to make this theory a reality. Additionally, integrating dark matter stabilizers into spacecraft design would involve overcoming significant engineering challenges. Despite these hurdles, the potential benefits are immense. A dark matter stabilizer could make space travel safer, more efficient, and more capable of exploring the universe's most extreme environments. It's a concept that pushes the boundaries of what's possible, offering a glimpse into a future where dark matter not only propels us through the stars but also keeps us steady along the way. Next, let's explore how dark matter could amplify energy outputs, enhancing spacecraft performance in ways we've only begun to imagine. Now, let's venture into a theory that could supercharge the capabilities of spacecraft in ways that sound almost like science fiction: dark matter as a cosmic energy amplifier. Imagine a spacecraft equipped with a system that not only generates energy but also amplifies it, allowing for unprecedented levels of performance. This is where dark matter could play a transformative role. The core idea revolves around leveraging dark matter's unique properties to enhance energy outputs. Dark matter, with its mysterious gravitational influence, could potentially interact with energy sources in ways that amplify their power. For instance, if a spacecraft is powered by a fusion reactor or solar energy, dark matter could act as a kind of cosmic booster, increasing the efficiency and output of these energy systems. This would mean more power for propulsion, life support, and scientific instruments, enabling longer and more ambitious missions. One possible application is in the realm of propulsion. By amplifying the energy generated by traditional propulsion systems, dark matter could allow spacecraft to achieve higher speeds without requiring additional fuel. This would be a game changer for interstellar travel, reducing the time it takes to reach distant star systems. Imagine a spacecraft accelerating to speeds previously thought impossible, all thanks to the energy-amplifying properties of dark matter. Another exciting possibility is in the area of energy storage. Dark matter could be used to enhance the capacity and efficiency of energy storage systems, allowing spacecraft to store more power for extended missions. This would be particularly useful in regions of space where energy sources are scarce, such as in the outer reaches of a solar system or in the void between stars. With dark matter as an energy amplifier, spacecraft could operate more independently, relying less on external energy sources. Of course, the challenges are significant. Harnessing dark matter to amplify energy would require a deep understanding of its interactions with conventional energy systems. Scientists would need to develop new technologies to detect, manipulate, and integrate dark matter into spacecraft designs. Advances in quantum physics and energy engineering would be essential to turn this theory into reality. Despite these hurdles, the potential rewards are immense. A dark matter energy amplifier could revolutionize space travel, making it faster, more efficient, and more capable of exploring the farthest reaches of the universe. It's a concept that pushes the boundaries of our imagination, offering a glimpse into a future where dark matter not only powers our journey through the cosmos but also amplifies our ability to explore it. Next, let's dive into how dark matter could reinforce spacecraft materials, making them more durable and resistant to the harsh conditions of space. Now, shifting our focus to another groundbreaking application of dark matter, let's explore how it could serve as a space-time distortion detector. Picture this: as spacecraft venture deeper into the cosmos, they encounter regions where space-time is warped by massive objects like black holes or neutron stars. Navigating through these distortions is no small feat, but dark matter might hold the key to making it easier. Dark matter's gravitational influence could be harnessed to detect subtle changes in space-time. Imagine a spacecraft equipped with sensors that use dark matter to identify and map these distortions. By doing so, it could chart safer and more efficient paths through the universe, avoiding hazardous areas or even using distortions to its advantage. This would be like having a cosmic GPS that not only guides you but also warns you of potential dangers ahead. One of the most exciting possibilities is using dark matter to detect gravitational waves, ripples in space-time caused by massive cosmic events like colliding black holes. These waves carry valuable information about the universe, but detecting them requires incredibly sensitive instruments. Dark matter, with its unique properties, could enhance the sensitivity of these detectors, allowing spacecraft to pick up even the faintest signals. This would open up new avenues for scientific discovery, helping us understand the universe in ways we never thought possible. Another application could be in the realm of interstellar navigation. Space-time distortions can affect the trajectory of a spacecraft, causing it to drift off course. By using dark matter as a distortion detector, spacecraft could make real-time adjustments to their paths, ensuring they stay on track even in the most chaotic regions of space. This would be especially useful for long-duration missions, where even a small deviation could lead to significant delays or missed targets. Of course, the challenges are immense. Developing the technology to detect and interpret space-time distortions using dark matter would require breakthroughs in both physics and engineering. Scientists would need to figure out how to isolate dark matter's gravitational effects from other cosmic phenomena and integrate this capability into spacecraft systems. But the potential rewards are worth the effort. A dark matter-based distortion detector could revolutionize space exploration, making it safer, more precise, and more capable of uncovering the mysteries of the universe. As we continue to push the boundaries of what's possible, the idea of using dark matter to detect space-time distortions offers a tantalizing glimpse into the future of space travel. Next, let's delve into how dark matter could act as a cosmic energy filter, protecting spacecraft and astronauts from harmful cosmic radiation. Now, let's turn our attention to another fascinating possibility, using dark matter as a cosmic energy filter. As spacecraft journey through the vast expanse of space, they are constantly bombarded by harmful cosmic radiation, high-energy particles that can damage equipment and pose serious risks to astronauts. Shielding against this radiation is one of the biggest challenges of space travel, but dark matter might offer a revolutionary solution. Imagine dark matter acting as a kind of cosmic sieve, filtering out dangerous radiation while allowing safe energies to pass through. This could be achieved by leveraging dark matter's unique interactions with other particles. Unlike ordinary matter, dark matter doesn't absorb or emit light, but its gravitational effects could be used to deflect or neutralize harmful cosmic rays. By creating a shield infused with dark matter, spacecraft could effectively block radiation without the need for bulky, heavy materials traditionally used for protection. One of the most exciting aspects of this theory is its potential to enhance the safety of long-duration missions. Astronauts traveling to Mars or beyond would face prolonged exposure to cosmic radiation, which increases the risk of cancer and other health issues. A dark matter-based energy filter could provide continuous protection, ensuring the well-being of crew members throughout their journey. This would not only make space travel safer, but also open up new possibilities for human exploration of the solar system and beyond. Another application could be in protecting sensitive equipment on spacecraft. Cosmic radiation can interfere with electronics, causing malfunctions or data corruption. By integrating dark matter into the design of spacecraft systems, engineers could create a built-in defense mechanism that safeguards critical components. This would reduce the need for redundant systems and heavy shielding, making spacecraft lighter, more efficient, and better suited for long-distance travel. Of course, turning this theory into reality would require significant advancements in our understanding of dark matter. scientists would need to figure out how to manipulate dark matter on a practical scale and integrate it into spacecraft technology. But the potential benefits are immense. A dark matter-based energy filter could revolutionize space travel, making it safer, more sustainable, and more capable of supporting human life in the harsh environment of space. As we continue to explore the possibilities of dark matter, the idea of using it as a cosmic energy filter highlights its potential to address some of the most pressing challenges in space exploration. Next, we'll dive into how dark matter could serve as a spacecraft recycling system, transforming waste materials into valuable resources during long missions. Now, let's shift gears and explore a concept that could transform how we manage resources during long space missions, using dark matter as a spacecraft recycling system. One of the biggest challenges of extended space travel is the limited availability of resources. Astronauts need food, water, oxygen, and materials for repairs, but carrying everything they need from Earth is impractical. What if dark matter could help us recycle waste into valuable resources, turning trash into treasure in the depths of space? Imagine a spacecraft equipped with a dark matter-based recycling system. This system could break down waste materials like food scraps, packaging, and even human waste, and convert them into usable resources such as water, oxygen, or raw materials for 3D printing. Dark matter's unique properties might allow it to interact with matter in ways that facilitate this transformation, potentially through processes we haven't yet discovered. By harnessing dark matter, we could create a closed-loop system where nothing goes to waste, ensuring sustainability on long journeys. The implications of this technology are enormous. For missions to Mars or beyond, where resupply from Earth isn't an option, a dark matter recycling system could be a game changer. Astronauts could generate their own oxygen from recycled carbon dioxide, produce water from waste, and even manufacture tools or spare parts from discarded materials. This would drastically reduce the need to carry heavy supplies, making spacecraft lighter and more efficient. It could also extend mission durations, enabling humans to explore farther into the cosmos than ever before. But how might this work in practice? One possibility is that dark matter could act as a catalyst, speeding up chemical reactions that break down waste into its basic components. Alternatively, dark matter's gravitational effects could be used to manipulate matter at a molecular level, separating useful elements from waste. While these ideas are still speculative, they highlight the potential for dark matter to revolutionize resource management in space. Of course, developing such a system would require groundbreaking advancements in both dark matter research and recycling technology. Scientists would need to uncover how dark matter interacts with ordinary matter and find ways to control those interactions. But the potential rewards are immense. A dark matter-based recycling system could make space travel more sustainable, cost-effective, and capable of supporting human life for extended periods. As we continue to push the boundaries of space exploration, the idea of using dark matter to recycle waste underscores its potential to solve some of our most pressing challenges. Next, we'll delve into how dark matter could serve as a cosmic energy transmitter, enabling spacecraft to receive power across vast distances. Now, let's turn our attention to an idea that could redefine how spacecraft stay powered during their journeys through the cosmos, using dark matter as a cosmic energy transmitter. One of the greatest challenges of interstellar travel is the need for a reliable and continuous energy source. Traditional methods like solar panels or nuclear reactors have their limits, especially when venturing far from the sun or into regions where energy is scarce. But what if dark matter could act as a bridge, transmitting energy across the vast emptiness of space to keep our spacecraft running? Picture this: a spacecraft equipped with a dark matter energy receiver, capable of tapping into a network of energy transmitted through the invisible fabric of the universe. Dark matter, with its mysterious gravitational influence, might be able to carry energy waves across immense distances without the loss or degradation that plagues conventional methods. This could allow spacecraft to receive power from distant stars, black holes, or even specially designed energy stations scattered throughout the galaxy. The result, a virtually limitless energy supply that could sustain missions far beyond our solar system. The concept hinges on the idea that dark matter could interact with energy in ways we don't yet fully understand. For instance, dark matter particles might be able to channel or amplify energy waves, creating a kind of cosmic power grid. This grid could transmit energy from one point to another, much like how electricity travels through wires but on a galactic scale. Imagine a spacecraft traveling to Proxima Centauri, receiving a steady stream of energy from a transmitter near Earth or another star system. This would eliminate the need for bulky fuel reserves or massive solar arrays, making spacecraft lighter, faster, and more efficient. But how might this work in practice? One possibility is that dark matter could act as a medium for energy transmission, similar to how fiber optics carry light. Energy could be encoded into dark matter particles and sent across space, where it's decoded and converted into usable power by the receiving spacecraft. Alternatively, dark matter's gravitational effects could be harnessed to create energy pathways, guiding power from one location to another with pinpoint accuracy. While these ideas are still in the realm of theory, they open up exciting possibilities for the future of space travel. The implications of a dark matter energy transmitter are profound. It could enable missions to distant star systems, power interstellar colonies, and even support the exploration of galaxies beyond our own. By removing the limitations of traditional energy sources, dark matter could unlock a new era of exploration where distance is no longer a barrier to discovery. As we continue to explore the potential of dark matter, the idea of using it as a cosmic energy transmitter reminds us of its transformative power. Next, we'll dive into how dark matter could serve as a spacecraft defense mechanism, protecting our vessels from the dangers of the cosmos. Now, let's shift our focus to a theory that could revolutionize how we protect spacecraft on their journeys through the cosmos, using dark matter as a defense mechanism. Space is a dangerous place filled with threats like asteroids, micrometeoroids, and even potential hostile forces. Traditional shielding methods, such as thick metal plating or advanced materials, can only do so much, especially when facing the unpredictable dangers of deep space. But what if dark matter could offer a new layer of protection, one that's both invisible and incredibly effective? Imagine a spacecraft surrounded by a dark matter shield, a kind of invisible force field that deflects or absorbs incoming threats. Dark matter's unique gravitational properties could be harnessed to create a protective barrier around the vessel, bending the trajectories of asteroids or micrometeoroids away from the ship. This wouldn't just protect the spacecraft from physical damage, it could also shield astronauts from harmful cosmic radiation, which poses a significant risk during long missions. One way this might work is by using dark matter's gravitational influence to create a distortion field around the spacecraft. Just as dark matter bends light around galaxies, it could be manipulated to bend the paths of incoming objects, effectively redirecting them away from the ship. Alternatively, dark matter could be used to absorb the energy of impacts, dissipating the force before it reaches the spacecraft's hull. This would make the vessel far more resilient to collisions, even at high speeds. But the potential of dark matter as a defense mechanism doesn't stop there. In a more advanced scenario, dark matter could be used to detect and neutralize hostile forces. For instance, if a spacecraft were to encounter an aggressive entity, whether artificial or extraterrestrial, dark matter could be deployed to create a cloaking effect, rendering the ship invisible or undetectable. This would give the crew a significant tactical advantage, allowing them to evade threats or launch countermeasures without being seen. The implications of this technology are staggering. A dark matter defense system could make interstellar travel not only safer but also more feasible, opening up new possibilities for exploration and colonization. Missions to distant star systems, which currently seem fraught with danger, could become routine with spacecraft protected by an invisible, impenetrable shield. This would mark a major leap forward in our ability to explore the universe, ensuring that humanity's journey into the stars is as safe as it is ambitious. As we continue to explore the mysteries of dark matter, its potential as a defense mechanism reminds us of the incredible possibilities that lie ahead. Next, we'll delve into how dark matter could act as a cosmic energy converter, transforming the very fabric of space into a source of power for our spacecraft. Now, let's turn our attention to a theory that could redefine how spacecraft harness energy in the vastness of space, using dark matter as a cosmic energy converter. Imagine a future where the very radiation that poses a threat to astronauts and equipment becomes a valuable resource, powering our journeys across the stars. This concept taps into the idea that dark matter, with its mysterious properties, could be the key to unlocking a nearly limitless energy source. Cosmic radiation is abundant in space, streaming from stars, black holes, and other celestial phenomena. While it's a hazard to both humans and electronics, what if we could flip the script and turn this radiation into usable energy? Dark matter, with its unique interactions with gravity and other forces, might hold the answer. By designing systems that allow dark matter to interact with cosmic radiation, we could potentially convert this harmful energy into a clean, efficient power source for spacecraft. One possible approach involves using dark matter as a kind of cosmic filter. Just as dark matter bends light and influences the paths of particles, it could be engineered to capture and redirect cosmic radiation into energy harvesting systems. These systems would then convert the radiation into electricity or other forms of power, providing a continuous energy supply for long-duration missions. This would eliminate the need for bulky fuel reserves or reliance on solar panels, which lose effectiveness as spacecraft travel farther from the sun. Another intriguing possibility is that dark matter could act as a catalyst, enhancing the efficiency of energy conversion processes. For instance, dark matter particles might interact with cosmic radiation in ways that amplify the energy output, making the conversion process far more effective than current technologies. This could lead to spacecraft that are not only self-sustaining but also capable of generating surplus energy, which could be stored or used to power advanced systems like propulsion or life support. The implications of this technology are profound. A spacecraft equipped with a dark matter energy converter could travel indefinitely, powered by the very environment that once posed a threat. Missions to distant star systems, which currently seem constrained by energy limitations, could become far more feasible. This would open up new frontiers for exploration, allowing us to venture deeper into the cosmos than ever before. As we continue to explore the potential of dark matter, its role as a cosmic energy converter reminds us of the untapped resources that surround us in space. Next, we'll examine how dark matter could serve as a spacecraft communication relay, enabling real-time communication across the vast distances of the universe. Now, let's shift our focus to a groundbreaking idea that could revolutionize how we stay connected across the vast expanse of space, using dark matter as a spacecraft communication relay. Imagine a future where messages travel seamlessly between Earth and distant star systems, overcoming the immense distances and delays that currently hinder interstellar communication. Dark matter, with its pervasive presence and unique gravitational influence, might just hold the key to making this vision a reality. One of the biggest challenges in space exploration is maintaining real-time communication over interstellar distances. Traditional radio waves, which we rely on today, become weaker and slower as they travel across light years, making it nearly impossible to send and receive messages efficiently. But what if dark matter could act as a cosmic relay station, amplifying and transmitting signals across the universe? This concept hinges on the idea that dark matter's gravitational effects could be harnessed to create a network of communication nodes, enabling faster and more reliable data transfer. Here's how it might work. Dark matter's gravitational influence could be used to bend and focus electromagnetic signals, such as radio waves or even laser beams, across vast distances. By strategically positioning spacecraft equipped with dark matter-based relay systems, we could create a series of interconnected nodes that boost and redirect signals, ensuring they reach their destination without significant loss of strength or clarity. This would effectively create a cosmic internet, allowing for real-time communication between Earth and distant colonies or exploration teams. Another fascinating possibility is that dark matter could serve as a medium for entirely new forms of communication. For instance, dark matter particles might interact with neutrinos or other exotic particles, enabling the transmission of information through channels that are currently beyond our technological reach. This could open up entirely new ways of sending and receiving data, potentially bypassing the limitations of traditional electromagnetic communication altogether. The implications of this technology are staggering. A dark matter communication relay system would not only enhance our ability to explore the cosmos, but also enable the coordination of interstellar missions with unprecedented precision. Astronauts on distant worlds could stay in constant contact with mission control, sharing discoveries and receiving instructions in real time. This would transform our approach to space exploration, making it more collaborative, efficient, and far-reaching. As we continue to unravel the mysteries of dark matter, its potential as a communication relay reminds us of the untapped possibilities that lie hidden in the fabric of the universe. Next, we'll explore how dark matter could act as a cosmic energy reservoir, storing and releasing energy to power the spacecraft of the future. Now, let's turn our attention to another fascinating possibility: dark matter as a cosmic energy reservoir. Picture this: what if the invisible fabric of the universe could not only power our spacecraft, but also store vast amounts of energy for future use? This idea takes the concept of energy storage to a cosmic scale, offering a solution to one of the most pressing challenges in space exploration: how to sustain long-duration missions without running out of power. Dark matter's unique properties make it an intriguing candidate for energy storage. Unlike conventional batteries or fuel sources, which have limited capacity and degrade over time, dark matter could potentially store energy indefinitely, thanks to its mysterious and stable nature. The key lies in harnessing dark matter's interactions with other particles or forces, allowing us to tap into its energy reserves when needed. One way this could work is by converting energy into a form that dark matter can absorb and hold. For instance, excess energy generated by a spacecraft's solar panels or nuclear reactors could be transferred into dark matter particles, effectively charging them like a cosmic battery. When the spacecraft requires additional power, this stored energy could be released, providing a steady and reliable source of fuel for propulsion, life support, or scientific instruments. Another possibility is that dark matter itself could generate energy through its interactions with ordinary matter or other cosmic phenomena. For example, when dark matter particles collide or decay, they might release bursts of energy that could be captured and utilized. This would create a self-sustaining energy cycle, reducing the need for external fuel sources and enabling spacecraft to operate independently for extended periods. The implications of a dark matter energy reservoir are profound. Imagine a spacecraft embarking on a decades-long journey to a distant star system, powered not by finite fuel reserves but by an endless supply of energy stored in the fabric of the universe. This would eliminate the need for frequent refueling missions or the reliance on fragile energy sources, making interstellar travel more feasible and sustainable. As we continue to explore the potential of dark matter, Its role as a cosmic energy reservoir highlights the incredible possibilities that lie ahead. Next, we'll delve into how dark matter could enhance spacecraft navigation systems, guiding us through the cosmos with unparalleled precision. Now, let's shift our focus to a concept that could revolutionize how we navigate the cosmos: dark matter as a spacecraft navigation aid. Imagine a future where spacecraft don't rely solely on traditional star maps or GPS-like systems, but instead harness the gravitational influence of dark matter to chart their course through the universe. This idea opens up a new frontier in space travel, offering a level of precision and reliability that could transform our ability to explore distant star systems. Dark matter's gravitational effects are already known to shape the structure of the universe, influencing the motion of galaxies and other cosmic bodies. What if we could tap into this invisible network to guide our spacecraft? By mapping the distribution of dark matter, we could create a kind of gravitational highway that helps spacecraft navigate through space with unparalleled accuracy. This would be especially useful in regions where traditional navigation methods like star tracking become unreliable due to the absence of visible landmarks. One way this could work is by using dark matter's gravitational pull as a reference point. Spacecraft equipped with advanced sensors could detect the subtle gravitational signals emitted by dark matter concentrations, allowing them to triangulate their position in real time. This would eliminate the need for constant communication with Earth-based systems, making long-distance missions more autonomous and efficient. Think of it as a cosmic version of GPS, but one that works across interstellar distances. Another exciting possibility is that dark matter could help spacecraft avoid hazards in space. By detecting gravitational anomalies caused by dark matter, navigation systems could alert spacecraft to potential dangers, such as asteroid fields or unstable regions of space-time. This would not only improve safety but also optimize travel routes, saving time and energy on long journeys. The implications of using dark matter as a navigation aid are immense. It could enable spacecraft to travel farther and faster than ever before, opening up new possibilities for exploration and discovery. Picture a mission to a distant exoplanet, guided by the invisible hand of dark matter, arriving at its destination with pinpoint accuracy. This technology could be the key to unlocking the secrets of the universe, one precise journey at a time. As we continue to explore the potential of dark matter, its role as a navigation aid highlights the incredible synergy between science and technology. Next, we'll dive into how dark matter could act as a cosmic energy redistributor, optimizing the performance of spacecraft systems for even greater efficiency. Now, let's explore a fascinating concept that could redefine how spacecraft manage their energy: dark matter as a cosmic energy redistributor. Picture this: a spacecraft traveling through the vastness of space, its systems running at peak efficiency thanks to the invisible influence of dark matter. This theory suggests that dark matter could play a crucial role in balancing and redistributing energy within spacecraft, ensuring optimal performance even on the most demanding missions. At the heart of this idea is the unique ability of dark matter to interact with energy in ways we're only beginning to understand. While dark matter doesn't emit or absorb light, its gravitational effects could be harnessed to channel energy more effectively within a spacecraft's systems. Imagine a scenario where excess energy from one system, like propulsion, is seamlessly transferred to another, such as life support or communication, without any loss or inefficiency. This could prevent energy bottlenecks and ensure that every part of the spacecraft operates at its best, even during extended missions. One potential application of this theory is in managing the energy demands of long-duration space travel. Spacecraft often face challenges in balancing power consumption across various systems, especially when resources are limited. By using dark matter as a medium for energy redistribution, we could create a self-regulating system that dynamically allocates energy where it's needed most. For example, during a critical maneuver, energy could be temporarily diverted from non-essential systems to propulsion, ensuring the spacecraft has the power it needs to complete the task safely. Another exciting possibility is that dark matter could help mitigate energy fluctuations caused by external factors, such as solar flares or cosmic radiation. These events can disrupt a spacecraft's energy systems, leading to potential malfunctions or even mission failure. By acting as a stabilizing force, dark matter could absorb or redistribute these energy surges, protecting the spacecraft and its crew from harm. This would not only enhance safety but also extend the lifespan of the spacecraft's components, reducing the need for repairs or replacements. The implications of this theory are profound. By optimizing energy distribution, dark matter could enable spacecraft to travel farther, faster, and more efficiently than ever before. It could also pave the way for more advanced technologies, such as self-sustaining spacecraft that require minimal external input to maintain their operations. Imagine a future where spacecraft are powered by the very fabric of the universe, their systems perfectly balanced by the invisible hand of dark matter. As we continue to unravel the mysteries of dark matter, its potential as a cosmic energy redistributor offers a glimpse into a future where space travel is not only possible but also incredibly efficient. Next, we'll delve into how dark matter could enhance life support systems, ensuring the survival of astronauts on long missions through the cosmos. Now, let's shift our focus to a theory that could revolutionize the way astronauts survive and thrive during long space missions: dark matter as a spacecraft life support enhancer. Imagine a scenario where the very fabric of the universe helps sustain human life in the harshest environments of space. This theory proposes that dark matter could play a pivotal role in improving life support systems, ensuring astronauts have the resources they need to survive and stay healthy on extended journeys. At the core of this idea is the potential for dark matter to interact with the systems that keep astronauts alive. Life support systems are critical for providing oxygen, regulating temperature, removing carbon dioxide, and managing waste, all essential functions for survival in space. However, these systems are often energy-intensive and require constant maintenance. Dark matter, with its unique gravitational and energy-related properties, could offer a solution to these challenges by enhancing the efficiency and reliability of life support technologies. One way dark matter could improve life support is by optimizing energy usage. As we've discussed earlier, dark matter has the potential to redistribute energy within spacecraft systems. This capability could be applied to life support, ensuring that energy is allocated precisely where and when it's needed. For example, during periods of high activity, such as spacewalks or repairs, dark matter could help divert additional energy to oxygen generation or temperature regulation, preventing strain on the system and ensuring the crew's safety. Another exciting possibility is that dark matter could act as a stabilizer for life support systems. Space is an unpredictable environment with fluctuations in temperature, radiation, and other factors that can disrupt critical systems. Dark matter's gravitational influence could help absorb or mitigate these disruptions, maintaining stable conditions inside the spacecraft. This would not only protect the crew but also reduce the risk of system failures, which could be catastrophic during long missions. Additionally, dark matter could play a role in recycling and reusing resources more efficiently. Life support systems often rely on closed-loop systems to recycle water and air, but these processes can be energy-intensive and prone to inefficiencies. By harnessing dark matter's properties, we could create more advanced recycling mechanisms that require less energy and produce fewer waste products. This would extend the lifespan of resources, making long-duration missions more sustainable and reducing the need for resupply missions from Earth. The implications of this theory are profound. By enhancing life support systems, dark matter could enable astronauts to undertake missions that were previously considered too risky or impractical. Imagine a future where spacecraft are equipped with self-sustaining life support systems, powered and stabilized by dark matter, allowing humans to explore distant planets and moons with confidence. This could open up new possibilities for colonization, scientific discovery, and even the search for extraterrestrial life. As we continue to explore the potential of dark matter, its role as a life support enhancer offers a glimpse into a future where space travel is not only possible but also safe and sustainable. Next, we'll dive into how dark matter could stabilize energy outputs, preventing fluctuations in spacecraft systems and ensuring smooth operations during even the most challenging missions. Now, let's turn our attention to a theory that could ensure the smooth operation of spacecraft systems, even in the most demanding conditions: dark matter as a cosmic energy stabilizer. Picture this: a spacecraft hurtling through the void of space, its systems running flawlessly, with no sudden spikes or drops in energy. This theory suggests that dark matter could be the key to achieving such stability, preventing dangerous fluctuations that could jeopardize missions. Energy stability is crucial for the success of any space mission. Spacecraft rely on a delicate balance of power to operate everything from propulsion systems to life support, communication arrays, and scientific instruments. However, space is filled with unpredictable forces, solar flares, cosmic radiation, and gravitational anomalies that can disrupt energy flow and cause systems to fail. Dark matter, with its unique gravitational and energy-related properties, could provide a solution by acting as a stabilizer for these energy outputs. One way dark matter could achieve this is by absorbing and redistributing excess energy. Imagine a scenario where a sudden surge of solar energy threatens to overwhelm a spacecraft's power grid. Dark matter integrated into the energy system could absorb this excess energy and release it gradually, preventing damage to sensitive equipment. This would not only protect the spacecraft but also ensure a steady supply of power even in the face of external disturbances. Another possibility is that dark matter could act as a buffer against energy fluctuations caused by internal factors. For example, during high-energy operations like engine burns or data transmissions, the demand for power can vary dramatically. Dark matter could help smooth out these fluctuations, ensuring that energy is delivered consistently and efficiently. This would reduce wear and tear on the spacecraft systems, extending their lifespan and improving overall reliability. Moreover, dark matter's stabilizing influence could enhance the performance of advanced technologies like ion drives or plasma thrusters. These systems require precise energy management to operate effectively, and even minor fluctuations can reduce their efficiency. By integrating dark matter into the energy infrastructure, we could create a more stable environment for these technologies, enabling faster and more efficient space travel. The implications of this theory are far-reaching. A spacecraft equipped with dark matter-based energy stabilization could undertake longer, more ambitious missions with greater confidence. Astronauts would no longer need to worry about sudden power failures or system malfunctions, allowing them to focus on exploration and discovery. This could pave the way for missions to the outer reaches of our solar system and beyond, where energy stability is even more critical. As we continue to explore the potential of dark matter, its role as a cosmic energy stabilizer offers a promising avenue for improving the reliability and safety of space travel. Next, we'll delve into how dark matter could reinforce spacecraft materials, making them more durable and resistant to the harsh conditions of space. Now, let's shift our focus to a theory that could revolutionize the very structure of spacecraft: dark matter as a material reinforcer. Imagine a spacecraft built with materials so strong and resilient that they can withstand the harshest conditions of space: extreme temperatures, micrometeoroid impacts, and intense radiation. This theory proposes that dark matter could be the key to creating such advanced materials, offering unprecedented durability and protection for future missions. Spacecraft materials face immense challenges in the unforgiving environment of space. Traditional materials, while effective, have their limits. Prolonged exposure to cosmic radiation can weaken structural integrity, while micrometeoroid impacts can cause significant damage. Even the extreme temperature fluctuations between sunlight and shadow can stress materials, leading to cracks or failures over time. Dark matter, with its unique properties, could provide a solution by reinforcing these materials at a fundamental level. One way dark matter could achieve this is by interacting with the atomic structure of spacecraft materials. Picture dark matter particles weaving themselves into the molecular bonds of metals, polymers, or ceramics, effectively strengthening them from within. This reinforcement could make materials more resistant to wear and tear, reducing the risk of damage from impacts or radiation. For example, a spacecraft hull reinforced with dark matter could better withstand micrometeoroid strikes, ensuring the safety of astronauts and the integrity of the mission. Another possibility is that dark matter could act as a self-repairing agent. Imagine a scenario where a spacecraft's outer layer sustains minor damage from a micrometeoroid. Dark matter-infused materials could detect the damage and initiate a repair process, filling in cracks or gaps at the molecular level. This self-healing capability would not only extend the lifespan of spacecraft, but also reduce the need for costly and risky repairs during missions. Additionally, dark matter could enhance the thermal properties of spacecraft materials. Spacecraft often experience extreme temperature variations, from the intense heat of direct sunlight to the freezing cold of shadowed regions. Dark matter-reinforced materials could better regulate these temperature changes, preventing thermal stress and maintaining structural stability. This would be particularly valuable for missions to distant planets or moons, where temperature extremes are even more pronounced. The implications of this theory are profound. Spacecraft built with dark matter-reinforced materials could undertake longer, more ambitious missions with greater confidence. They would be better equipped to handle the rigors of deep space exploration, from asteroid belts to the outer reaches of the solar system. This could open up new possibilities for human and robotic missions, enabling us to explore environments that were previously considered too hazardous. As we continue to explore the potential of dark matter, its role as a material reinforcer offers a promising avenue for advancing space travel. Next, we'll dive into how dark matter could harvest energy from cosmic phenomena, providing a powerful and sustainable energy source for spacecraft. Now, let's venture into an idea that could redefine how spacecraft power themselves in the vastness of space: dark matter as a cosmic energy harvester. Imagine tapping into the immense energy of cosmic phenomena like black holes or neutron stars, not through traditional means, but by harnessing the mysterious properties of dark matter. This theory suggests that dark matter could act as a bridge, allowing us to capture and convert the energy of these cosmic giants into a usable form for space travel. Black holes and neutron stars are among the most energetic objects in the universe. Black holes, with their intense gravitational pull, can generate enormous amounts of energy as they consume matter. Neutron stars, on the other hand, spin at incredible speeds, emitting powerful radiation and magnetic fields. Both of these phenomena release energy on a scale that dwarfs anything we can produce on Earth. The challenge, however, lies in accessing and converting this energy into something practical for spacecraft. This is where dark matter comes in. One possibility is that dark matter particles could interact with the energy emissions from black holes or neutron stars, acting as a kind of cosmic antenna. These particles might absorb the energy and then transfer it to a spacecraft's systems, effectively turning dark matter into a conduit for power. For instance, a spacecraft equipped with dark matter-based energy harvesters could position itself near a neutron star, capturing its radiation and converting it into electricity to fuel its engines and instruments. Another intriguing idea is that dark matter could amplify the energy it collects. Picture dark matter particles acting like tiny energy reservoirs, storing the immense power of cosmic phenomena and releasing it in controlled bursts. This could provide spacecraft with a steady and reliable energy source, even in the most remote regions of space. Such a system would be invaluable for long-duration missions, where traditional energy sources like solar panels or nuclear reactors might fall short. The potential applications of this theory are staggering. A spacecraft powered by dark matter energy harvesters could explore regions of the universe that are currently beyond our reach. It could venture close to black holes, study neutron stars up close, or even travel to the edges of our galaxy. The ability to harness energy from these cosmic phenomena would not only extend the range of our missions, but also open up new possibilities for scientific discovery. As we continue to explore the mysteries of dark matter, its role as a cosmic energy harvester offers a tantalizing glimpse into the future of space travel. Next, we'll uncover how dark matter could revolutionize data storage on spacecraft, enabling advanced computing and exploration capabilities. Now, let's shift our focus to a concept that could transform how we handle information in the depths of space: dark matter as a spacecraft data storage system. Imagine a future where the vast, invisible presence of dark matter isn't just a mystery but a tool for storing and processing unimaginable amounts of data. This theory proposes that dark matter could serve as the ultimate hard drive for spacecraft, enabling advanced computing and exploration capabilities far beyond what's possible today. Data storage is a critical challenge for space missions. As we venture further into the cosmos, the amount of information we collect, from high-resolution images to complex scientific measurements, grows exponentially. Traditional storage systems like solid-state drives or magnetic tapes have limitations in terms of capacity, durability, and energy efficiency. They also take up valuable space and weight on spacecraft, which are already constrained by the need to carry fuel, instruments, and life support systems. This is where dark matter could offer a groundbreaking solution. One possibility is that dark matter particles could be manipulated to store data in a way that's far more compact and efficient than current technologies. Picture dark matter acting like a quantum hard drive, where information is encoded in the unique properties of these particles. Because dark matter doesn't interact with light or electromagnetic forces, it could potentially store data without the risk of degradation from cosmic radiation or other environmental factors. Another intriguing aspect of this theory is the idea of scalability. Dark matter is believed to make up a significant portion of the universe's mass, meaning there's an almost limitless supply of it. If we could harness even a fraction of this for data storage, spacecraft could carry vast libraries of information without the need for bulky hardware. This would be especially useful for long-duration missions, where the ability to store and retrieve large datasets is crucial for scientific research and navigation. But how would this work in practice? One concept involves using dark matter's gravitational influence to create stable data structures. For example, a spacecraft could generate tiny gravitational fields using dark matter particles, encoding information in the patterns of these fields. These patterns could then be read and decoded by onboard computers, providing a highly efficient and durable storage solution. Additionally, because dark matter is so abundant, this system could be scaled up or down as needed, making it adaptable for a wide range of missions. The implications of this technology are profound. A spacecraft equipped with dark matter-based data storage could carry entire encyclopedias of knowledge, detailed maps of the galaxy, or even the collective wisdom of humanity. It could also enable real-time data processing and analysis, allowing astronauts to make faster, more informed decisions during their missions. This would be a game-changer for exploration, opening up new possibilities for discovery and innovation. As we continue to unravel the mysteries of dark matter, its potential as a data storage system offers a glimpse into a future where the invisible fabric of the universe becomes a cornerstone of space travel. Next, we'll explore how dark matter could regulate environmental conditions on spacecraft, ensuring the survival and comfort of astronauts on long journeys. Now, let's turn our attention to a theory that could redefine how spacecraft harness energy in the vastness of space: dark matter as a cosmic energy converter. Imagine a scenario where the mysterious forces of dark matter and dark energy, which together make up the majority of the universe, are no longer just theoretical concepts but practical tools for powering interstellar travel. This theory suggests that dark matter could act as a bridge, converting the elusive energy of dark energy into a usable power source for spacecraft. Dark energy, the force driving the accelerated expansion of the universe, is one of the most enigmatic phenomena in cosmology. While its effects are observable on a cosmic scale, harnessing it directly has remained a distant dream. However, dark matter, with its gravitational influence and unique properties, might hold the key to unlocking this potential. The idea here is that dark matter particles could interact with dark energy in a way that transforms its expansive force into a stable, controllable energy source. One possible mechanism involves using dark matter as a mediator. Since dark matter interacts gravitationally, it could be manipulated to create localized fields that capture and channel dark energy. These fields could then convert the energy into a form that spacecraft systems can utilize, such as electricity or propulsion. Think of it as a cosmic power plant, where dark matter acts as the machinery that processes raw dark energy into something tangible and practical. The advantages of such a system are immense. Unlike traditional energy sources, which rely on finite resources like fuel or solar power, dark energy is abundant and omnipresent throughout the universe. A spacecraft equipped with a dark matter-based energy converter would have access to a nearly limitless power supply, enabling it to operate indefinitely without the need for refueling. This would be particularly transformative for missions to distant star systems, where energy constraints are a major limiting factor. Another exciting aspect of this theory is its potential for scalability. Dark matter's widespread presence means that energy conversion systems could be designed to suit a variety of spacecraft sizes and mission requirements. From small probes to massive interstellar vessels, the ability to tap into dark energy could revolutionize how we approach space exploration, making long-duration missions not only feasible but sustainable. Of course, the challenges are significant. Understanding the precise nature of dark matter and dark energy and how they interact is still a work in progress. Developing the technology to manipulate these forces would require breakthroughs in both physics and engineering, yet the potential rewards are too great to ignore. A spacecraft powered by dark energy converted through dark matter could unlock new frontiers in exploration, enabling humanity to venture further into the cosmos than ever before. As we continue to explore the possibilities of dark matter, its role as a cosmic energy converter offers a tantalizing glimpse into a future where the invisible forces of the universe become the engines of our interstellar ambitions. Next, we'll delve into how dark matter could regulate environmental conditions on spacecraft, ensuring the survival and comfort of astronauts on long journeys. Now, let's shift our focus to a theory that could transform the living conditions aboard spacecraft, making long-duration missions not just possible but comfortable: dark matter as a spacecraft environmental regulator. Imagine a future where the invisible presence of dark matter isn't just a cosmic mystery, but a vital tool for maintaining the delicate balance of life-supporting environments in space. This theory explores how dark matter could be harnessed to regulate temperature, air quality, and even gravity within spacecraft, ensuring the survival and well-being of astronauts on extended journeys. One of the biggest challenges of space travel is creating a stable, habitable environment in the harsh conditions of space. Traditional life support systems rely on complex machinery and finite resources, which can be prone to failure or depletion over time. Dark matter, with its unique gravitational and possibly even electromagnetic properties, could offer a revolutionary solution. By interacting with the spacecraft's environment, dark matter might help stabilize temperature fluctuations, ensuring that astronauts are neither too hot nor too cold, even in the extreme conditions of deep space. Another critical aspect of habitability is air quality. Maintaining breathable air and removing harmful gases like carbon dioxide is essential for long-term missions. Dark matter could potentially act as a filter or regulator, interacting with the molecular composition of the air to remove toxins and replenish oxygen levels. This would reduce the need for bulky and resource-intensive air filtration systems, freeing up valuable space and energy for other mission-critical functions. Gravity, or the lack thereof, is another major concern for astronauts. Prolonged exposure to microgravity can lead to muscle atrophy, bone density loss, and other health issues. Dark matter's gravitational influence might be harnessed to create localized artificial gravity fields within the spacecraft. By manipulating dark matter particles, it could be possible to simulate Earth-like gravity, providing astronauts with a more natural and healthy environment during their missions. The potential applications of dark matter as an environmental regulator extend beyond just habitability. It could also enhance the efficiency of spacecraft systems by reducing the energy and resources needed to maintain life support. For example, instead of relying on power-hungry heating and cooling systems, dark matter could passively regulate temperature through its interactions with the spacecraft structure and surrounding space. This would not only conserve energy but also increase the overall reliability of the spacecraft systems. Of course, the challenges of implementing such a system are significant. Understanding how dark matter interacts with matter and energy on a microscopic scale is still a major area of research. Developing the technology to manipulate dark matter for environmental regulation would require groundbreaking advancements in both physics and engineering. However, the potential benefits are immense. A spacecraft equipped with dark matter-based environmental regulation could support longer, safer, and more comfortable missions, paving the way for humanity's expansion into the cosmos. As we continue to explore the possibilities of dark matter, its role as an environmental regulator offers a glimpse into a future where the invisible forces of the universe become the guardians of human life in space. Next, we'll explore how dark matter could amplify energy from stars, providing a powerful and sustainable energy source for spacecraft. Now, let's turn our attention to a theory that could redefine how spacecraft harness energy in the vastness of space: dark matter as a cosmic energy amplifier. Picture this dark matter, the invisible scaffolding of the universe, not just existing passively but actively boosting the energy we can extract from stars. This idea opens up the possibility of creating a nearly limitless energy source for interstellar travel, one that could power spacecraft far beyond the capabilities of current technologies. Stars are already incredible powerhouses, radiating immense amounts of energy across the cosmos. But what if we could amplify that energy even further? Dark matter, with its mysterious properties, might hold the key. Scientists theorize that dark matter could interact with the energy emitted by stars, enhancing it in ways we've never imagined. Imagine a spacecraft equipped with a dark matter-based energy amplifier, capable of capturing and magnifying starlight to generate unprecedented levels of power. This could eliminate the need for traditional fuel sources, allowing spacecraft to travel farther and faster than ever before. One of the most exciting aspects of this theory is its potential to solve one of the biggest challenges in space exploration: energy scarcity. Current spacecraft rely on solar panels, nuclear reactors, or chemical fuels, all of which have limitations. Solar panels, for instance, lose efficiency as a spacecraft moves farther from the sun. Nuclear reactors, while powerful, come with safety and resource constraints. Dark matter energy amplification could provide a cleaner, more sustainable solution, tapping into the abundant energy of stars without the drawbacks of conventional systems. But how exactly could dark matter amplify energy? One possibility lies in its gravitational influence. Dark matter's gravitational pull could bend and focus starlight, concentrating it into a more intense beam of energy. This process, similar to how a magnifying glass focuses sunlight, could allow spacecraft to capture and utilize far more energy than they currently can. Another idea involves dark matter particles interacting with photons, the particles of light, to increase their energy levels. This interaction could effectively supercharge starlight, making it a far more potent energy source. The implications of this theory are staggering. A spacecraft powered by amplified starlight could travel to distant star systems without the need for refueling stops. It could also support more advanced onboard systems, from powerful propulsion engines to sophisticated life support technologies. This could make long-duration missions not only feasible but also more efficient and cost-effective. Of course, there are significant hurdles to overcome. Understanding how dark matter interacts with light and energy is still a major challenge. Developing the technology to harness and amplify starlight using dark matter would require breakthroughs in both astrophysics and engineering. Yet the potential rewards are immense. A future where dark matter amplifies the energy of stars could unlock new frontiers in space exploration, enabling humanity to reach the farthest corners of the galaxy. As we continue to explore the possibilities of dark matter, its role as a cosmic energy amplifier offers a tantalizing glimpse into a future where the stars themselves become our fuel. Next, we'll delve into how dark matter could enhance traditional propulsion systems, making spacecraft faster and more efficient than ever before. Now, let's shift our focus to a theory that could revolutionize how we think about spacecraft propulsion: dark matter as a propulsion enhancer. Imagine taking the traditional engines we use today and supercharging them with the mysterious power of dark matter. This idea isn't just about incremental improvements, it's about unlocking a new era of space travel, where speed and efficiency reach levels we've only dreamed of. Traditional propulsion systems like chemical rockets or ion drives have served us well, but they come with limitations. Chemical rockets, for example, require massive amounts of fuel, which adds weight and reduces efficiency. Ion drives, while more efficient, produce relatively low thrust, making them better suited for long, slow journeys rather than rapid interstellar travel. Dark matter, with its unique properties, could offer a way to overcome these challenges, enhancing propulsion systems to achieve greater speeds with less energy. One way dark matter could enhance propulsion is by interacting with the fundamental forces that drive spacecraft. For instance, dark matter's gravitational influence could be harnessed to create a kind of gravitational assist effect, where a spacecraft uses the gravitational pull of dark matter to gain momentum. This would be similar to how spacecraft currently use the gravity of planets to slingshot themselves through space, but on a much larger scale. By leveraging dark matter's gravitational field, spacecraft could achieve faster speeds without needing additional fuel. Another possibility involves dark matter's potential to manipulate space-time. If dark matter could be used to create localized distortions in space-time, it might allow spacecraft to ride these distortions, effectively reducing the energy required to travel vast distances. This concept draws from the idea of warp drives, but instead of creating a full warp bubble, dark matter could provide smaller, more manageable distortions that enhance traditional propulsion methods. The implications of this theory are profound. A spacecraft equipped with a dark matter-enhanced propulsion system could travel to distant star systems in a fraction of the time it currently takes. Missions to Proxima Centauri, our nearest stellar neighbor, could become feasible within a human lifetime. Even within our own solar system, dark matter-enhanced propulsion could make trips to the outer planets faster and more efficient, opening up new opportunities for exploration and discovery. Of course, there are significant challenges to overcome. Understanding how dark matter interacts with traditional propulsion systems is still a major hurdle. Developing the technology to harness dark matter's properties for propulsion would require breakthroughs in both physics and engineering, but the potential rewards are immense. A future where dark matter enhances spacecraft propulsion could transform our ability to explore the cosmos, making interstellar travel not just a possibility but a reality. As we continue to explore the possibilities of dark matter, its role as a propulsion enhancer offers a thrilling glimpse into a future where the stars are within our reach. Next, we'll explore how dark matter could create a network of energy sources across the universe, powering spacecraft on their journeys through the cosmos. Now, let's venture into a concept that could redefine how spacecraft are powered across the cosmos: dark matter as a cosmic energy network. Picture this: a vast, invisible web of energy sources scattered throughout the universe, all connected by the mysterious properties of dark matter. This network could serve as a universal power grid, enabling spacecraft to tap into energy reserves no matter how far they travel from Earth. The idea hinges on dark matter's unique ability to interact with the fabric of the universe. Unlike ordinary matter, dark matter doesn't emit light or energy in ways we can easily detect, but its gravitational influence is immense. Scientists theorize that dark matter could act as a conduit for energy, channeling it across vast distances through its gravitational fields. Imagine a spacecraft equipped with a dark matter energy receiver, capable of drawing power from this cosmic network as it journeys through the stars. One way this could work is by using dark matter's gravitational pull to harvest energy from cosmic phenomena like black holes, neutron stars, or even the remnants of ancient supernova. These high-energy events release enormous amounts of power, but much of it is lost in the void of space. Dark matter, however, could capture and redistribute this energy, creating a network of power stations that spacecraft could access. This would eliminate the need for bulky fuel reserves or limited onboard energy sources, allowing for longer, more ambitious missions. Another possibility involves dark matter's potential to store and transmit energy. If dark matter particles can be manipulated to hold energy, they could act as cosmic batteries, storing power until it's needed. Spacecraft could then plug in to these energy reserves, recharging their systems without ever needing to return to Earth. This would be especially useful for missions to distant star systems, where traditional energy sources would quickly run out. The implications of a dark matter energy network are staggering. It could enable spacecraft to travel farther and faster than ever before, without the constraints of fuel or energy limitations. Missions to the farthest reaches of the galaxy could become routine, and the dream of exploring other star systems could finally become a reality. Even within our own solar system, this network could revolutionize space travel, making it easier and more efficient to explore planets, moons, and asteroids. Of course, there are challenges to overcome. Understanding how to harness dark matter's energy storing and transmitting capabilities is still a major scientific hurdle. Developing the technology to tap into this cosmic network would require groundbreaking advancements in both physics and engineering, but the potential is undeniable. A future where dark matter powers our spacecraft through a universal energy network could unlock the full potential of interstellar exploration. As we look ahead, the idea of a dark matter energy network offers a tantalizing vision of a connected universe where energy flows freely and the stars are no longer out of reach. Next, we'll explore how dark matter could enable spacecraft to traverse not just space, but time itself, opening up possibilities that were once confined to the realm of science fiction. Now, let's take a leap into one of the most mind-bending possibilities of dark matter, its potential to enable time travel. Imagine a future where spacecraft don't just traverse the vastness of space, but also navigate the currents of time itself. This isn't just science fiction, it's a theory grounded in the mysterious properties of dark matter and its relationship with the fabric of the universe. At the heart of this idea is the concept that dark matter could interact with space-time in ways we're only beginning to understand. According to Einstein's theory of general relativity, massive objects like stars and black holes can warp space-time, creating gravitational fields that influence the flow of time. Dark matter, with its immense gravitational influence, could take this a step further. Scientists speculate that dark matter might be capable of creating extreme distortions in space-time, potentially opening pathways for time travel. One way this could work is through the formation of closed time-like curves, theoretical loops in space-time that could allow an object or a spacecraft to travel back to its own past. Dark matter's gravitational effects might be harnessed to stabilize these curves, making them accessible for practical use. Imagine a spacecraft equipped with a dark matter-based propulsion system, capable of bending space-time to create a stable time loop. This could allow astronauts to travel to a specific point in time, observe historical events, or even alter the course of history, though the ethical implications of such power are staggering. Another possibility involves dark matter's role in creating wormholes, hypothetical tunnels through space-time that connect distant points in the universe. While wormholes are still purely theoretical, dark matter could provide the gravitational energy needed to keep them open and stable. A spacecraft passing through such a wormhole might not only travel vast distances in an instant, but also emerge in a different time period altogether. This would revolutionize space exploration, allowing us to visit distant star systems and eras simultaneously. Of course, the challenges are immense. Manipulating dark matter to create stable time loops or wormholes would require technology far beyond our current capabilities. We'd need to understand how to control dark matter's gravitational effects with precision, a task that remains firmly in the realm of theoretical physics. Additionally, the energy requirements for such feats would be astronomical, pushing the boundaries of what we consider possible. Yet, the potential is undeniable. A future where dark matter enables time travel could transform our understanding of the universe and our place within it. It could allow us to witness the birth of stars, the formation of galaxies, or even the origins of life itself. The implications for science, history, and philosophy are profound, opening up questions about causality, free will, and the nature of reality. As we conclude our exploration of dark matter's potential, it's clear that this mysterious substance holds the key to unlocking some of the universe's greatest secrets. From propulsion systems to energy networks, and now to the possibility of time travel, dark matter could revolutionize not just how we explore space, but how we perceive time itself. The future of space travel may be closer than we think, and it might just involve bending the very fabric of reality. As we wrap up this journey through the 50 groundbreaking theories on harnessing dark matter for space travel, it's impossible not to feel a sense of awe at the possibilities. From propulsion systems that defy our current understanding of physics to energy networks that could power entire civilizations, dark matter stands as a cornerstone of futuristic exploration. Each theory we've explored, whether it's creating warp drives, stabilizing wormholes, or even enabling time travel, paints a picture of a universe brimming with potential, waiting for us to unlock its secrets. Imagine a future where spacecraft glide effortlessly through the cosmos, powered by the invisible forces of dark matter. Picture a world where interstellar travel is as routine as a cross-country flight, where humanity reaches distant stars and galaxies, not just as explorers but as pioneers of a new era. The transformative potential of dark matter isn't just about technology, it's about redefining what it means to be human in a universe filled with mysteries. But this future isn't just for scientists or dreamers, it's for all of us. Every theory we've discussed invites you to imagine, to question, and to wonder. What if dark matter could be the key to unlocking faster than light travel? What if it could protect us from cosmic dangers or even allow us to witness the birth of stars? The possibilities are as vast as the universe itself, and they're waiting for us to take the next step. So, what do you think? Could dark matter be the key to humanity's greatest achievements in space travel? Let us know your thoughts in the comments below. We'd love to hear your ideas and theories. And if you're as fascinated by the future as we are, don't forget to hit that subscribe button and ring the notification bell. There's so much more to explore, and we can't wait to take you on the next adventure into the unknown. Until then, keep dreaming, keep questioning, and keep looking to the stars. The future is closer than you think.